Okay, let's get started on our next session. My name is Eric Bastian, and I'm very pleased to be able to introduce the two gentlemen that are going to take us through the rest of our day. We're going to have a fairly intensive piece on food safety. We've talked about how important it is. I think it was, who was it this morning said, you can't get somebody sick, right? That's a surefire way to destroy a business. And so the idea of having a safe food supply is really critical. And there's a lot of detail in developing a food safety plan around, a program. So we want to get into that. But I have a couple of points I want to make first. I'm married to Julie. And I remember Julie going to the fridge, and she opened it up, and she said, "Hey, Eric, there's no cheddar cheese in here, and I got to have it for my recipe." And I said, "Well, there's a piece of Danish pearl in there. Can you try that?" And so she did. And then the same thing happened, and I said, on another occasion, I said, "Hey, there's a piece of I got all different kinds of cheeses in there because I try to support some of our gentlemen who were up here earlier. So I always have Ballard's cheese in there, and I have Beehive cheese in there. But there's a promontory in there, so she used that. So now the problem I get into is when she's cooking and she goes to the fridge and there's no promontory, she's on to me. "How come there's no promontory here? This is better than the cheddar," she says. So that's the progression that we're kind of getting into with some of our consumers, and my wife is part of that. So that's the first point. Second point, milk is an absolute complex. I think it's the most complex food we deal with, okay? And I've spent my life trying to understand it, and I barely scratched the surface of it. So there's a lot of stuff that we can do with milk. And so we talk about these niche areas. There's all kinds of things, all kinds of product, things we haven't even discovered yet that we can do with milk. And so I'd love to be part of the journey with any of you, just to brainstorm some ideas and talk about some niche opportunities that might be there for you. So use me if you feel like you would like to talk. I have no problem talking about this. Do I have a problem talking about milk with somebody? No. Next point. Cheese is a biological happening, okay? So as much as we try to control it, it eludes us sometimes. It gets away from us. We have viruses that infect the cultures that we add to our cheese. So we're always trying to fight against these viruses that coming around. It's not only us as humans fighting against COVID, it's our cheese cultures fighting against the bacteriophage that are trying to take them out of our cheese system. And I've had a vat of cheese that I was making. The pH was coming down. It got about halfway where I needed it to be, and then it flatlined. That's when you know that you have a bacteriophage, a virus, that has infected and destroyed the culture that you're trying to make your cheese with. So I would just want to make that point that some of these things we just have to work around and deal with. Now, having said all of that, I need to get our people who are going to train us on food safety in front of you today. I want to introduce Sam Alcaine. Sam, come up here by me, will you? Sam is a professor at Cornell University, and I have to say that he has been active in going across the United States and teaching food safety. He has a curriculum developed. You've got the books in front of you, so please look at those. The slide deck is here. The slides, as I understand it, are all duplicated in the book, right, Sam? Sam comes to us from Cornell University, where he's an assistant professor, and his research there is focused on dairy fermentations, where he's upscaling some of our byproducts into more value add. Things like permeate he would be using for fermentation. He has a bachelor's degree from the University of Maryland, a master's degree at Cornell, so he came back to Cornell. You must have loved his master's program there, and a PhD at the University of Massachusetts in Amherst. So with that, I'm going to turn the time over to Sam, and then as well, should I introduce Taylor now or later?
Give him an introduction now.
All right, so we're going to have Taylor Oberg as well come up. Now, Taylor comes from a dairy family. I've known his father for years as a researcher and a professor at Weber State University. His younger brother works in development over at Chobani, and Taylor now is at Utah State University as a dairy microbiologist, but he spent 5 years working at Leprino ahead of that. So if you want to talk pizza cheese, he's your guy. And so with that, I'm going to turn the podium to Sam and Taylor. Thank you.
Thank you for the introduction, Eric. And I'm going to see, does this one come out? There we go. Because I don't like being tethered to the stage. And it's also kind of nice going after the lawyers, because usually when they see the food safety guys come in the room, everyone's like, oh no, they're going to talk about how we're going to make everybody sick. This isn't going to be fun. So the lawyers talked a lot about the bad stuff. So I think it'll be easier going on out here. And the point of today is to kind of get you exposed to food safety. So kind of understand for the crowd, where is everyone in their journey in moving into the cheese market? How many people here have actually already started producing? Has anyone here started to produce? There's a few. Our panel has started to produce. So has anyone started building anything? So everyone is really kind of in the exploratory phase right now, looking into this. So when we go into this this food safety plan session here, let's get my little pointer going. Food safety is a journey, okay? And so today, has anyone here taken any food safety courses so far? Any food safety education? I see a small hand, a hand here, right? Again, right, you're going to hear this again and again, so this is going to be a first set of exposure for you. You're going to hear some new words, some new terminology, but just remember you're going to continue taking these courses. Alan, I think, mentioned, right, the Bible of the PMO. Today we're going to be talking about the Food Safety Modernization Act, and I'd call that the New Testament that just came out, okay? That changes the way we think a lot about food safety. And again, this is going to be kind of an introduction to this. That's going to be part of your business going forward, and it is a manageable part. I think people will speak to that. As part of this whole program, Taylor and I are going to be presenting today. As Eric mentioned, we've been running a series of workshops for the past 3 years around the country that are really around coaching artisan producers around developing their food safety plans and understanding that process, and it's been a collaborative work. So it's between me at Cornell, Dennis D'Amico at the University of Connecticut, Clint Stevenson at NC State, the Innovation Center for U.S. Dairy, and then regional universities and guild partners throughout the country have really helped us spearhead this program, which is kind of coming to an end with our grant money, but we, and I'll talk about it in just a little bit, we'll have a new version of that program starting up this year that will hopefully make it even more accessible to starting dairy producers around the country. So what are we going to be covering today? And this is kind of a loose agenda. It'll be based also somewhat on the timing, but the idea today is kind of give you an overview of the core components of what are required for your food safety plan and what you need to be thinking about as you develop that. As I mentioned, usually this is a larger program. It's usually a 2-day coaching session where we'd sit down and help artisans write out their food safety plan. But that material for that kind of workshop is all on your desk. There's 2 books there, one that contains all the presentations that you're going to see today and some extra ones, and then another book that contains the templates that you'd be using to help you develop your food safety plans. And we'll use them as a light reference, but again, you're kind of starting off in this process, so we're not going to have you sit down and write everything. Kind of little responsibility statement that I use for all my artisan cheesemakers is that we're here to serve as resources to help you develop your food safety plans. But when you start into this business, right, it is going to be your own responsibility to manage and make sure that what you've developed is correct and is going to help you protect your consumers. So that's just a little piece there. So going on, so let's talk a little bit about our food safety plans and why we're interested in them. So we talked about how we don't want to make people sick, right? We don't want to find out that we have a problem too late. So this whole idea, and the panel before us was talking about a risk-based approach, risk management. Well, we want to take a risk management approach to food safety, and that's what the Food Safety Modernization Act is about. It's about figuring out, right, what are the key components for us to make safe cheese, okay? We want to identify them so that we can prevent them from happening in the first place rather than having a recall, right, or responding to it later. And again, a lot of you are early on in this process, but it's going to go hand in hand with a lot of other programs that we talk about later on, like good manufacturing practices and things like that. And again, the whole idea here is to have a plan ahead of time so that we know what we're going to do to ensure that we make safe foods. And so this Food Safety Modernization Act actually is 10 years old this year. So it's taken a little while to implement. And even the curriculum for teaching about the Food Safety Modernization Act isn't that old. It kind of, the teaching program, which this is based on from the Food Safety Preventive Controls Alliance, started in around 2016. So we're still training a lot of people. So what is this view around food safety? So how many people in the room are familiar with good manufacturing practices on the dairy side, right? So, that's kind of our good manufacturing practices and our hygienic practices with our workers and things like that all kind of make up our foundation for our food safety system. Now, in the pre-FSMA world, all right, we're going to be talking about this food safety plan now. In the pre-FSMA world, we had something called a hazard analysis. Anyone here familiar with HACCP? Hazard analysis, critical control points. I see another hand up. That was the previous world where we would do a hazard analysis to figure out what are the risks, right, to our products from a food safety perspective. And then we would design what we call in that era CCP, so critical control points to control those, which we now in this new terminology call process controls. And that was our HACCP plan. Alongside that, we might have things around allergen controls in our facility, which we will all have as dairy producers. We'd have things around how do we clean our equipment, so our sanitation practices. And we'd have things around, well, the ingredients that we're buying from our suppliers, how are those all handled? In the pre-FSMA world, these components all kind of resided in what we would call our prerequisite programs. And now, in the FSMA world, those programs, if they're designed to control a risk or a hazard in our food products, they now rise to the level of our food safety plan, and there's going to be now requirements, regulatory requirements around the type of documentation that we need to have in place to show our auditors that we are actually controlling these hazards. Okay? And then another requirement now in the FSMA world is, well, if we had a recall, you'd have to deal through that. You now have to have a written recall plan if you have a hazard in your facility. So again, so you're not developing how to respond to a worst case scenario on the fly. The idea again is to have a plan in place to make sure that you can respond to that unfortunate event if it happens. And then there's all sorts of documentation that's going to have to be in place to support this entire program. So things like, what are the procedures that we're actually going to follow to monitor pasteurization? Or what are the procedures that we're going to use to clean our vats? All those kind of things are going to need to be written, they're going to be monitored, and they're going to need to be verified that they happen. And that we'll touch on a little bit later today. But again, we're going to be focusing on the core of our food safety plan. So again, this is supposed to be a systematic approach to food safety. And so the idea here is that we're going to do a hazard analysis, or we're going to talk about the ingredients that we're using to make our cheeses, the process that we're using to make them. We're going to identify what hazards are associated with them, things that you may have heard in the news like listeria or an allergen, dairy allergen. We're going to identify ways that we're going to control those. We're going to figure out then, all right, what are the parameters and values that I need to measure, right, to know that I'm controlling them? How do I know that pasteurization is being performed properly? Any ideas from the crowd? What might I measure? Temperature, right? Exactly. So that'd be one of those things. Temperature, time. How am I actually going to monitor those? And then what am I going to do if, for some reason, my pasteurizer isn't working right and I don't hit my temperature? How do I correct that mistake to make sure that I don't release unsafe product into commerce? And then supporting all that, right, is going to be, I'm going to have documentation now so that when an auditor, either from the state or FDA, comes into my facility, that I can show them that I've implemented this plan the way that I said I was going to implement it and that it's done to protect people. So when we're thinking about our hazards, we've got to think about, where could they potentially come from? And so what are some potential sources for hazards coming into my facility? What should I be? Milk, right? Milk. That's right, one of my ingredients. Could be bringing in something. What else? What was that? Other ingredients, yeah. Other ingredients, right? If I'm rubbing, putting peanuts on the outside, or even coffee potentially, right? What do I got to think about there, right? Other pieces. Employees, right? And the people that work in my facility, right? can definitely bring in risks. They can transfer risks around my facility, so I need to be thinking about them. Packaging, potentially, right? How's my packaging being done? Does that introduce a risk? Yeah, that could be. Packaging is kind of getting onto one of the other areas. What's another source? Bacteria. Now, they're the actual hazard, right? But what's another source of them? Where are they hanging out besides on my people? Water. Water is a potential ingredient, yes, so you need to think about the treatment of your water. Yep. Machines, right? That's starting to get at, right? The things that surround my environment, right? So my processing floor, my walls, my ceilings, right? Those can all be potential sources of pathogens. And so when we're thinking about making safe product, we're going to be thinking about how each one of these areas can introduce a hazard into my facility and get into my dairy product, whether it's cheese, yogurt, ice cream, right? And then how do I protect against it? Which one of these do you think is the hardest to control? Environment. Why do you think environment?
Because of the walls, floors, drains,
People passing in and out of them. So what about those people, right? If those walls and drains, right? Yeah. Yeah, but it can be tough, right, to upkeep, right? And that's why it's important when you're thinking about constructing your facility. And there was a lot of discussion earlier about sitting down with consultants and really thinking through hygienic design. So that's important. A big challenge always is the people, right? And how they treat that environment, how they treat the ingredients. You give them instructions and they don't always follow them, right? And so sometimes people are our biggest challenge, which is why training and going through food safety education for yourself and as you start to develop your business for your employees and things like that are so important so they understand the importance of the procedures you put in place and why you make your cheese or your yogurt or your ice cream a certain way to make sure that it's safe. And so as we think about the sources of these hazards, eventually, right, as you develop your facility, you're going to have a process flow diagram to understand how you actually make your product. And you'll go through there and identify where in your process are you actually going to be controlling those hazards. And that will be our hazard analysis later for today. All right. Now, talking about the FSMA regulations, so one of the requirements in FSMA now is that you're going to develop this food safety plan, and the individual who is responsible for this food safety plan is going to need to be a preventative controls qualified individual. All right. So what does that mean? So a preventative controls qualified individual is an individual who has successfully completed training in the development and application of risk-based preventative controls at least equivalent to that received under a standardized curriculum recognized as adequate by FDA. And so for right now, what I'm going to be going over today with all of you is going to be based on the material developed by the Food Safety Preventative Controls Alliance, FSPCA. And they have a 2.5-day course that goes thoroughly through the regulations. And by taking that course, you become a PCQI individual. Now, so today's course doesn't get you PCQI. We're just kind of focusing on the highlights of this. But someone will have to go, eventually you or someone in your facility is going to need to go through that course. And the other option, and right now that is the only curriculum that is widely available out there. It's all open source and things like that, that is being taught around the FSMA regulations. There's some discussion about developing some other forms of education, but that quite hasn't happened yet because it took a lot of people already working together to develop the curriculum that FSPCA came up with. And then the other opportunity is that someone could also be qualified through job experience to develop and apply food safety systems. And you might argue that somebody with a long history in the dairy industry or consultant may naturally already have that experience, somebody like Eric or Taylor, right? But you'll still find that even all of those people, because there are some new pieces of terminology and requirements as part of the Food Safety Modernization Act, all of them still go through this course to make sure that they know everything is compliant. So you'll need to have a PCQI individual involved with you as you start to take this journey in developing a facility and understanding what your food safety requirements are. So some other definitions, and these are straight out of the regulation, right? So what is a food safety plan? And here's the stress. We talked about some documentation earlier for developing your business plans. Your food safety plan is also a written set of documents that's based on food safety principles that will incorporate these components that you're going to continue to hear over and over again today, because they are the key pieces. They're going to be your hazard analysis, your preventative controls that you identify to control those hazards, your supply chain program, if you're bringing in ingredients that you're not processing yourself, you're going to require to have a recall plan, and you're going to have written procedures, right, that you're going to be following for the production of your product, for those controls, for your sanitation and all those things, and you'll need to have corrective actions. What do you do? Again, you have to have a plan in place for what happens if something doesn't go the way you were planning. And then how do you verify that you're actually implementing this food safety plan the way you say you are? And then our total food safety system, which some people talked about a little bit earlier, is the outcome of implementing this food safety plan and supporting elements like our good manufacturing practices and hygienic components. So what does that look like? So the contents of our food safety plan. What is required per the regulation? We're required to have a hazard analysis. We're required to have these preventive controls, and they're going to fall under 4 buckets that we'll go into later this afternoon. Again, they're going to be called process controls, typically around controlling things like biological hazards like bacteria, but it could be things like viruses, depending on where the risks are coming from, or physical hazards. We'll talk about food allergens. I think one of the things here, so who here works with an allergen, right? Yeah. Everybody in this room works with an allergen. And again, in the old days, everyone would say, oh, well, of course, obviously, it's milk, it's cheese. Per the regulation, you're going to have some controls that may seem, right, self-evident around allergen controls. So you'll have to have that. We're going to have sanitation controls if there's a point in our process where our product is exposed to the environment after a process control. So a lot of our cheeses, right, we may pasteurize the milk, which would kill some of the pathogens that come in with the milk. But then we make our cheese is sitting out, and we talked about the environment being a potential source of a hazard. If something like Listeria gets from the environment into our cheese, now we have a problem. So we need to make sure that our environment is clean, that our equipment is clean, and so if it's exposed, we'll need to have a sanitation control, as opposed to, say, something like maybe you do a cup set yogurt, right? You take your yogurt milk, you pasteurize it, you quickly add your cultures, and then you package it and it's closed, right? That product is no longer exposed to the environment, so some of the controls you'll have later on will be different than, say, something like a cheese. You'll be required to have a recall plan. We all have a hazard associated with the foods that we're going to be making. So we're going to have a recall plan. There are exceptions for some products, say like a vinegar, where maybe it's really unlikely. But for all of us in the room, we're going to have a recall plan. And then we're going to have written procedures for monitoring our process, for what are we going to do again if something goes wrong, and how do we verify that we're implementing this all correctly. Now, per the regulation, these are our required steps and our required processes. What they don't require, which we argue is very useful, and I argue is very hard to do anything on the required column without doing these very useful factors first, is you're not required to have a facility overview, but I think that's important. You should identify who's going to be helping you develop this food safety plan, whether it's you, whether you have an outside consultant who's working with you. Who is that team? If you're a larger company, you might draw from people from different departments. Your quality department, your marketing department even is important to have a cross-functional team to think about all the potential challenges that you might have, so you're considering all the risks. You're going to want to have a written, even though you're not required, you should have a product description. Right, so what is the cheese that I'm making? What does it look like? What's its pH? What's its water activity? What's its salt content? All those things, having them written down, all those components can impact the safety of your food and what type of hazards you need to worry about. So having it in one place so you can look at it is important. A flow diagram of your process, right? So you're all, right now, it's a blank slate, but as you develop that, thinking about designing your process, that will lead into this flow diagram, and again, will help you identify the areas in your process where a hazard might come in, or you might have certain pieces of equipment that will help you then control those hazards. It's important to have that all lined out so you can walk through and do an effective hazard analysis. And then you're also going to want to have maybe some further descriptions of what those processing steps are. So, right, what are the exact time and temperatures that I'm doing for pasteurization, or what am I doing in my salting process? All those things might be helpful to help you understand what risks, and having it written down is important. Now, a lot of my small cheese makers that come through the coaching workshop is like, Sam, can't you just give us a little written document and we can just implement this? And every processing facility is different, and the products that you make will be different, even though, sometimes you might, be making a mozzarella, or you might be making cheddar. It may look similar, but as you dive down into the details, there may be differences. And so there's not a one-size-fits-all food safety plan. So it needs to be tailored to your facility. When we talk about the types of products, you may be able to group all your cheddar, all the cheeses that you make in your facility, or you may want to separate them out. And this is going to end up, as you get into this journey, you're not going to have to decide today. You'll have to think about that on how easy or difficult it makes you to develop your documentation. You're going to want to define, again, what specific products, acid set cheeses versus rennet set cheeses might be a line, or maybe there's a unique allergen to one of the products that you're making that isn't in the other. Those might be ways that you delineate it. You're going to think about where you are in the food chain, and for a lot of you, you're going to be spanning multiple spots, right? Because some of you are dairy farmers, so you're on the farm side, and now you're going to be transitioning to the processor side. And how do you delineate that control? And then in the next section, we'll be talking about what are the type of hazards that we're actually controlling. We'll talk a little bit about what are biological hazards, what are chemical hazards, what are physical hazards that we need to be thinking about before we start making our products. How are we going to put together this food safety plan? The format is pretty flexible. The curriculum tends to show a binder. You think about a written document, and a lot of people do print out their food safety plans into binders, but it can also be digital. But again, the general flow is going to flow from the regulations, and like we talked about, right? You're going to have a food safety plan. When you think about it at the end of the day, it's going to be this big document. It's going to have that background information to kind of give, and which is important to give your auditor when they come into your facility to understand what you're doing. Set them up with the story so they don't have any questions, right? And then you're going to go through your hazard analysis. You'll have identified your controls for those hazards. You'll have a written recall plan, and you'll have these implementation procedures, which are the procedures that you're going to be following, right, to make your products or clean your equipment and things like that. So again, we talked a little bit about this useful information and why you should have it. When we talk about our hazard analysis, this is really the heart of the food safety plan, is doing an adequate hazard analysis to make sure you've identified what are the actual risks for your facility. You don't want to miss them, because then you're not controlling a potential food safety hazard, and then you will have a recall. Again, those types of controls, and we're going to be diving into each of these controls later on in the afternoon. You're going to have sections on your process preventative controls, your food allergens, which encompass things like labeling. Someone mentioned labeling earlier. There are requirements just around general requirements around labeling, but as part of your food safety plan, you're going to have requirements around labeling your allergens. If you have unique allergens in your facility, you might have things around cross-contact, so cleaning that equipment to make sure an allergen doesn't wind its way up in one product from another. You're going to have sanitation preventative controls to make sure that you're controlling the environment so that there aren't any pathogens that can easily make their way into your product, and that your equipment is being cleaned appropriately so they don't serve as a source of contamination. And there may be other preventative controls. I haven't seen other categories, but you never know. And then if you're buying ingredients, and we'll talk a little bit more about this in the supply chain section, if you're buying ingredients that you are not then controlling the hazards associated with them, then you're going to need to work with your supplier to understand how you're going to control those. And that's going to be called a supply chain preventative control. You're going to need to have a recall plan, and everyone in this room is going to be required to have a recall plan when you have a hazard in your facility. And again, it needs to delineate how are you going to recall that product from market. Who do you need to call? Who are the public health officials that you need to work with, because they'll be working closely with you? Who are the retailers you need to contact? How do you get the information to your consumer? And how do you track whether or not you've gotten back all the product or not? So that'll all be delineated in this recall plan. And then our implementation procedures are going to encompass things like Validation studies. Why did I put in, pasteurization? We won't need to do a validation study for that because that's a well-documented process. But there might be things out there, like maybe you're looking at a novel technology. Has anyone heard of high-pressure pasteurization? I see a couple head shaking. So it's a process where they basically imagine they use really high pressure, like if you're at the bottom of the Pacific Ocean, right? The weight of all that water on you, that high pressure can be used to inactivate bacteria, right? But it's still a very novel technology. So you might go to a university agency. Cornell, we have a facility that validates high pressure pasteurization in different products, and you'd go there and work with the university to prove that for your product, that pasteurization process inactivates the bacteria that you're concerned about, and then you could show that to FDA when they come to your facility to say, hey, this is why I'm using HPP. So that might be an example of where you might have a validation study. Your implementation procedures will also, again, include the procedures for monitoring. So I'm going to do pasteurization. How am I going to monitor the temperature? What are those logs look like? Those written logs, your pasteurizer temperature chart, right? Those are all pieces of our implementation procedures. And we'll be talking a little bit more about that too later in the day. And then our implementation records will be, again, a lot of the documentation that we generate as we're actually making our product. So our daily logs, right, of producing product. Those pasteurizer charts will be on there. The chart temperatures, the chart logs for our refrigerators might be on there. Our labels, that we made sure that we applied the right labels, all those things will be part of our implementation records. And as we go through, as we generate these records for our facility, we're going to need to keep them for at least 2 years. And then every 3 years, at a minimum, we're going to have to go back and re-review our food safety plan to make sure that it is up to date and that there hasn't been any changes to our processing environment. And maybe sooner, if you do actively decide to install a new piece of equipment, as somebody was talking about, adding a new area to your facility, right? That will be a requirement to go back and re-review your food safety plan to make sure that it's up to date. So I know this kind of feels like this, right? A little bit of a bed of nails to be jumping into, and we're going to be talking more about it. But really, the food safety plan, has anyone ever sat on a chair of nails or a bed of nails, lay down? It's actually not that painful, right, if you distribute your weight correctly. And it's kind of the way with the food safety plan. It looks very daunting, but, right, it's doable, right? The panel that we had up here earlier, right, you guys have worked through identifying what the hazards are, developing a food safety plan. Even coming from a world that was a lot of you started producing before FSMA was implemented, and then changing into that new mindset. And so it is accomplishable, and it's working with teams, collaborating, and you'll be able to get there. Now, for those of you starting off, though, there are some options to start making the journey a little bit easier. So there is an exemption attestation, right? Depending on the size of your facility. So this is something to definitely think about. So this attestation gets you out of some of the requirements around the Food Safety Modernization Act, at least in spirit, if not completely. So what is a qualified facility? How do I take advantage of this attestation? So a qualified facility is a business when including the sales by any subsidiary affiliates and any entity with which the facility is a subsidiary or affiliate with an average annual sales of less than $500,000, with at least half of the sales to consumers, right, direct to consumer, or to local retailers or restaurants, or reservations within the same state or 275 miles. If that defines your business, you have an exemption to these FSMA requirements. Or if you're a very small business, averaging less than $1 million, adjusted for inflation in both the sales of human food plus the market value of any food that you have in your manufacturing facility. So if you're aging cheese, the value of that cheese goes into that calculation. If that yearly average over a 3-year period is less than $1 million, then you qualify for this exemption, okay? Now, earlier, I'm not a business guy, but we talked a little bit about the way you organize your business units. And one of the things to think about is, if you have a large dairy facility right now, if your business, your cheese business, your ice cream business is a subsidiary or part of that dairy business, and you're making, your dairy's already making more of that money, you're going to be required to be compliant with the full set of FSMA. There's no way to get out of that. You won't have that exemption. So think about how you structure those businesses and talk to the lawyers in the room, because that can make an impact. So I've definitely had, producers where, someone in the family was like, oh, I'm going to, start a side cheese making project, off of the dairy business, and it'll be part of that. And then FDA comes in and they're requiring you to run, have all the same systems in place that a large dairy has. And that can be very difficult. So that's one thing to be thinking about as you get into this adventure. But if you do qualify for this exemption, then what you can do is you can submit an attestation form to FDA. And what that attestation form is saying here on that column on the right-hand side of the screen is that you are then attesting that you have gone through, even if it's not written right there for them to see, that you've gone through and you've done a hazard analysis to understand what the hazards are in your facility, and that you've developed the appropriate preventative controls and monitoring for those controls to make safe food, and that you're complying then with any non-federal food safety regulations, so state and county health regulations. You'll submit that form to FDA. So you're still essentially doing what we talked about. The difference is that when FDA comes in to audit you, they're not going to go through and require that you present all the same documentation that you would have to do if you were fell under the entire regulation of FSMA. So, but you need to actively, here on the bottom there, and I don't have my pointer, you need to actively attest to FDA. If you don't, they're going to assume that you are required to be compliant with the entire set of the regulations. And so what does that mean? What it means is, if you go through the regulations, there are all these subparts. And so if you're doing your attestation, you're still required to be compliant with subpart A, which is the general definitions. You're required to have good manufacturing practices and have those written out. It exempts you from parts of subpart C, so that hazard analysis and risk-based controls. It's not that you don't have to do them. You need to do them. It's just that when FDA comes in to audit you, they're not going to require, they're not going to demand to see that documentation from you, which is then that subpart D, the modified requirements. And then you'll still be required to have records in place, right, to document that you're doing the appropriate GMPs and things like that. And then you'll also be exempt from the supply chain program, which is around the ingredients that you purchase. But this big area in red here, FDA always saves a get-out-of-jail-free card. So if they decide that they have a reason, for example, maybe they've tested your product and they found a pathogen in it, to withdraw your qualified exemption, they can do that, and then and then require you to be compliant with the full set of the law. So that is something to think about. To do that attestation form, if you just, Google's wonderful, right, to find information. If you Google the qualified facility attestation, it'll pull up these links to FDA's website where you can go in and you can click, and then you can fill out the form. So you are required, right, and this information is a little bit older, but you are required to have submitted this form by December 17th, 2018 if you're already in processing. And if you're starting up, and this is all of you in the room, right, before beginning your operations, right, you need to submit this attestation form before you start up. So make sure that you have that on your checklist of what to do. And now one of the challenges, and I think a lot of the established cheesemakers in the room may attest to this, is that while you may in the start qualify as an exempt facility, if you're hoping to get into any retailers, right, a lot of the retailers like the Krogers, the Wegmans, the Whole Foods of the world require that their suppliers, right, the cheeses that they're buying from actually have a written food safety plan in place anyways. So you may be exempt from FDA's perspective, but from a commercial perspective, you'll be asked to supply this kind of documentation anyhow. And so it's important, again, to go through this food safety education and learn how to do it. All right. Now, some of the common challenges that we've seen throughout the years of working through food safety plans with small processors is, again, thinking through your process flow. Again, you're at the start of designing your facilities, but thinking through what are your processing steps versus a process description. So how do you develop that flow chart? Another thing is don't overthink your hazards, right? I mean, we've been making cheese for thousands of years. We've been making cheese in the food safety modernization world for now, a decade. And so a lot of the things that you need to think about, a lot of people have already thought about, so don't overthink it. And remember, dialogue with your inspectors and your auditors is important, and they're willing to have that. Someone also earlier mentioned when you're designing your facility, talking with your local regulators about what needs to be done to make sure that you have the right stuff in place. Because sometimes they may allow you to do something that you didn't think they would, or they might point out a challenge that they want you to have in place before you start up. So make sure you have dialogue with your inspectors and your public health officials. Other things are around small cheesemakers. How do you deal with the ingredients? Again, with a supply chain program that we'll talk about later, just sometimes you just need to do the due diligence to make sure you're buying from reputable companies and not just developing something on the fly. And also look towards working with established chemical suppliers. If they're not going to give you the type of information that you need through brokers, find somebody else, because there are a lot more companies out there requiring documentation support from their cleaning and sanitization producers, and you should be able to get that. Environmental monitoring, which Taylor will be talking about a little bit later. Start small. Don't dive in all the way. Take small steps until you get comfortable. And with your paperwork, there's a lot of documentation in the food safety plan, but try to keep it as simple as possible. When we talk about, just some of the issues over the year that FDA, usually every year, though with COVID it hasn't happened, FDA talks about some of the non-compliances that they see when they're out there doing audits against the food safety plan requirements. And the most common thing that they've been seeing is, again, a not appropriately done hazard analysis. That's number one. So that is the heart of your food safety plan. You think about doing that appropriately. Number two, sanitation controls, verification that they're doing the cleaning and sanitization properly, allergen controls, and then not having the right equipment design, right? It's non-sanitary. So again, important as you go to build your facilities and you're going to buy that first vat, make sure, right, that you've gone through and done the due diligence to ensure that that vat is constructed the right way so that it's cleanable, right, and won't end up being a source of pathogens later on. In 2019, again, they saw some of the similar challenges. Number one, making sure that you're doing the appropriate hazard analysis. Number two was some people still didn't have a food safety plan in place when FDA came knocking on their door. Sanitation controls is always a big one. And then process controls, which I think are pretty much more straightforward in the dairy industry, but for some other food products can be a challenge. Another thing that I'm just going to put out there in this part of this introduction on things to watch out for in the future is now that the food safety plan requirements have been implemented and people are following those, the next step in FSMA is going to be around traceability. And so this is something to be thinking about for the dairy industry. They're going to be adding requirements around the documentation required for tracing a food through the production process. And one of the top ones on that list is cheeses, right? Unpasteurized milk and soft and semi-soft cheeses. And exactly what these regulations are going to look like and what the requirements are and how we're going to teach about that is still kind of up in the air. But they've started putting out proposed rules for this traceability, and it's something to be aware of. Now, there are groups like IDFA and things like that that are talking to FDA to understand what are the exemptions for these traceability rules. But right now, unlike the food safety plan regulations, there are not exemptions for small producers. So just keep that on your radar. And then as part of just this early stage before we dive into the specifics of the food safety plan is, what are other resources and practical tools that are out there for me as a dairy producer, as a cheesemaker? One of the key things that I'd point to that was developed in collaboration with the American Cheese Society and the Innovation Center for U.S. Dairy and a bunch of universities and extension programs, is we have a website called safecheesemaking.com, and you go here and it is a repository of information on food safety plan development, on resources, training modules, and things like that. So as you're going through this process, go to that website and check it out. There are also other educational programs, food safety education. Some of you are just diving into this. You're going to be taking classes all the time, right, and learning all the time. As you know, how often do you go to a food safety class now that you've been in the business, right? Almost yearly, right? You know, at least there's going to be a session at a conference you go to or whatever like that, and it's always a good reminder, and you're going to be building, and it's going to take time for all of it to stick in your head. So reminders are important. So there are a lot of programs that have been developed to help support artisan dairy producers. There is a food safety basics online course from NC State that was also developed in collaboration with the Innovation Center at U.S. Dairy that kind of walks you through some of the basic foundations for food safety. So it'd be important for you and for any future employees to take. There are other university programs at Cornell. We have a basic dairy science and sanitation course that walks you through the basics of dairy chemistry and dairy cleaning. I'm sure Utah also has programs like that, so it'll be closer for you to take. We've also got programs in Spanish. Today, we're not going to spend a lot of time on good manufacturing practices because it is a very big section. But there is an online program around good manufacturing practices that was developed in partnership with FDA at Cornell, and it's a 12-module program that's available online, which is a great way to deep dive because this is a course you could take for 2 days to understand what those requirements are, and I highly recommend taking it. And then I mentioned that I was part of this coaching workshop program that we were taking around the country, and we just received a grant from USDA, myself in collaboration with Oregon State University. So the team over there, Joyce Wade-Kuzek and Yvonne Kovacevic, and then with Clint Stevenson at NC State, where we are taking this coaching workshop, what used to be done in person, and we would travel around the country doing it, which was great to have one-on-one time with small producers, but it's hard to get everybody in the room, and as you start up your facilities, right, you have the time is limited, right? So what we're doing is we're going to be translating the coaching workshop into an online format where all our lectures will be available as a video online, and then we're going to have what we call virtual office hours multiple times a month, where small dairy producers from around the country can just kind of zoom in and talk about a specific food safety topic and ask questions of food safety experts. So that's going to be starting up this fall. And then another piece of that is that we'll still have some in-conference workshops or presentations like we're doing today in association with the American Cheese Society. And also if you're into ice cream, there is the National Ice Cream Retailers Association that has a yearly convention that we're going to be working with on developing that, or delivering those type of workshops. So those are the preliminary things out there. Again, just the overview for the introduction on the food safety plan, right? We're going to now, as we're developing our facilities, we're going to need to have a written food safety plan that's specific to our facility that we're building. It's going to be required to have a hazard analysis to identify what are the types of risks that I need to control for from a food safety and health perspective. Those preventative controls then that control those hazards are going to fall into buckets that we're going to dive into later this afternoon. They're called process controls, allergen controls, sanitation controls, and supply chain controls. We're going to be required to have a written recall plan, and we're going to need to have written procedures for how we're going to do all of this. The format's flexible, but a binder is kind of the best way to think about it. So that's kind of the initial introduction to the food safety plan, and now we're going to be kind of diving into what are hazards and what is a hazard analysis. But give everyone a few minutes. Are there questions, thoughts, shocked looks from the audience? What's
I'm just curious on the documentation. Has any of that gone to app or can you get app function?
right? So So the question here is for the documentation, right? Because there's a lot to keep track of. Are there any apps or programs out there that help you with that? So there is a program out there developed by FDA that's called the Food Safety Plan Builder, which only works on a PC, and it helps. Yeah, Taylor's. It does. I will say the benefit of the Food Safety Plan Builder is that it does walk you through the hazard analysis in a very stepwise manner, but it is not a very flexible program as you develop dynamic products, and so. Sometimes doing it by hand or with an Excel sheet. A lot of the templates that are in that book are available online, and you can fill them out on your computer. I have not seen anyone develop a great app to enable cheesemakers to track all this process and all this documentation. It's come up many times in the coaching workshops. I even had one guy who was an engineer that was getting into cheese making, who was thinking about, maybe I should actually do a business developing these applications. But to my knowledge, he hasn't actually run that way. So that is an opportunity. I don't know, Taylor, have you? I haven't seen any. Yeah, unfortunately. So.
People just use like a form of these outlines
And,
and generate their own stuff.
no. And any of the cheesemakers here that have established programs, have you found any good applications, right? So is it mostly spreadsheets and Word documents, right? And I've seen the nods. Yeah. So, yeah, I wish I had a better solution. I do see some people using things like waterproofed iPads and things like that to help them record things in the make room and then storing it digitally, but it's homegrown applications. Yeah. Yeah. Other questions from the? Yeah. Oh, comments too is great. Yeah. Yeah.
Sam's the man. For me, Dennis D'Amico, his colleague, was the person that was up speaking at the short courses, and I haven't heard anybody speak like Dennis until Sam. He's a huge resource. There's not that many people in the U.S. that understand all of this complex stuff and can kind of make it digestible. And so I'm not signing you up for too many emails and phone calls, but that's the guy.
And I'm here. Dennis is there. Clint Stevenson, Taylor here, in some sense. But my role at the university is extension. So we also have. I think the email is dairyfoodsafety@cornell.edu, and if you email that, we've got a network of people that we will then send out your questions to help you address your food safety questions, because that's what we want to do. That's what we're there to provide as a free service. To help you on this journey. And we're actually also developing be up soon, a map of food safety resources across the country by state. So you'll be able to go to that map, click your state, and then there'll be a list of extension associates that you can reach out to, potentially some consultants we'll see, and then also universities and things like that. So again, if you go to that safecheesemaking.com site, a lot of that will be housed there. Yeah. Mm-hmm. All right, then we're going to start, because we have lunch at noon, right? We'll start this first process, this next section on what are our hazards and how to do a hazard analysis, and then break for lunch. All right, so hazards and hazard analysis, right? That's the way it feels, right? We're dipping our toes into the molten lava, and we want to make sure we do this safely. So at the end of this section, right, we're going to help you start thinking about what are the documents you're going to need for developing your food safety plan, how you're going to develop them. We're going to talk about, what are the preliminary steps and materials you need to help you do an adequate hazard analysis. What are hazards? What is this word hazards that we're talking about? What does that mean? What are their categories? We're going to talk about different areas, different resources you can reach out to or Google or pull up to help you think through this process. And then, again, traditionally in our coaching workshop, we'd have some time to develop these, but we'll just kind of overly be talking about what these steps and processes are. So again, as we saw, right, what are the required contents of our food safety plan? It's going to be this hazard analysis is the heart of it, identifying our controls, but we're also going to need this useful information over here on the right. So the way this process works, you kind of think about it sequentially, right? Or we're going to develop our preliminary documents. So we're going to describe our processing environment. We're going to talk about what are the products that we're making, what are their key characteristics that might have an impact on food safety. We're going to then perform a hazard analysis on these products, on our ingredients, on our equipment, on our environment, to identify where the hazards are, and then we're going to develop preventative controls, right? It seems very sequential. And it is to start, but it is also really a cyclical process, okay? Because what's going to happen is once we put our preventative controls in place, we're going to be monitoring them as we're producing. And we might end up finding that we might have problems that we didn't anticipate, which means we're going to have to go back and change, write our preliminary documents, and re-review the process, okay? The types of hazards that we're thinking about may change over time, and so we maybe need to go back and reevaluate our hazard analysis, or we may change the way we're making a product. We may introduce new types of products, and those all will require us to go back and reevaluate our hazard analysis, reevaluate our preliminary documents to make sure that we're capturing all the products that we're making, all the equipment and processes that we're using. So it is always a continuous process. It's not a one and done endeavor, right? It's a continuous journey. So when we're talking about hazards, what do we mean? A hazard is a biological, and here we're talking microbial hazard. There are chemical hazards. We'll talk about things like allergens, toxins from bacteria. Could be things like the chemicals that come in with our cleaning sanitizers and things like that. And then physical hazards that are likely or that are reasonably likely to cause foodborne illness or injury in the absence of a control, right? So, right, if I have contaminated milk and I don't do anything about it, someone is likely to get sick, right? Or if I have glass packaging in my facility and it's shattered, right, and I don't do anything to deal with that broken glass, it is likely to cause an injury if I don't have a program in place to deal with that physical hazard. So those are the types of hazards. Again, a key thing to remember here is reasonably likely to cause foodborne illness. If it's not reasonably likely, then you do not need to then have it in your hazard analysis. And again, what are the categories? A biological hazard might be something like a bacteria, listeria, salmonella, E. coli might be bacteria that you've commonly heard about in the news. It could potentially be something like a mold if it produces a toxin, maybe not. It could be viruses, things like hepatitis, things like norovirus might be something I need to think about. It could be parasites. I have emails just this week talking with a goat milk farmer in another area of the country where their goats, they found their goats have toxoplasmosis, they have Toxoplasma gondii, and they're selling raw milk, and so now they're trying to figure out what they should be doing. And so those are all kind of things to think about. Chemical hazards, again, will be like allergens, which are naturally part of some of our products, and we'll talk a little bit more about what those are. And then physical hazards, again, if we have metal, that might come from the equipment that we have in our facility. There might be foreign material that comes in with our ingredients. We need to think about those and whether or not they actually represent a hazard. When we talk about biological hazards, this is from the FSPCA material. Again, a lot of this information is already out there, so we don't need to rethink about it too much, but you need to make sure that you do the due diligence to look and see what's associated with the foods that you're producing. And so here you can see when we're talking about milk products, right, there are things like Campylobacter, Salmonella, Brucella, Mycobacterium, strep, soft cheeses, they talk about Listeria monocytogene. So already, right, you can begin to see a list of pathogens that I need to be thinking about when I'm developing my facility and thinking about how I'm going to control them to make sure that they don't end up being an issue for my consumer, and so I don't have a recall and I don't get somebody sick. This is from FSPCA. If you go to FDA, they have a guidance document that they've put out, which is another Bible to look at. If you go, again, just Google the draft guidance for industry on hazard analysis. You go to Appendix A, they have a large document that goes through and they highlight what are the top of mind biological hazards, physical hazards, and chemical hazards associated with different foods groups and different ingredients. So if you're gonna, it'll be pretty straightforward to go in and look for, a traditional cheese and milk and ice cream. But as you start to talk about inclusions, if you're making ice creams or you're doing unique rubs or unique things like that, it's a great resource to go in and look for to make sure you're not missing anything on those ingredients. So what isn't necessarily a hazard? So when we talk about risks to our products, Violation, we talked about standards of identity earlier. If you violate the standard of identity, you might get in trouble with whoever's watching the standard of identities. But when we're talking about our food safety plan and the FSMA requirements, they don't care whether or not your cheddar is compliant with the standard of identity for cheddar. So that would not be a hazard. Economic fraud is not necessarily a hazard, right? You may have like watered down milk, right, which would be economic fraud, but it's not necessarily a food safety hazard. There may be cases where there are. When we talk about, if everyone remembers now, maybe it's almost a decade ago now, we had the melamine incident with infant formula in China where they were putting in this chemical melamine because it has a lot of nitrogen in it, and the way you analyze protein content in milk, right, is looking for nitrogen content, and so they were able to swap it out. But melamine is toxic, and right, it killed children, and so that was an economic fraud that was a hazard. So you might think if I'm buying dairy powders from a certain part of the world, maybe I need to have something looking into that, but that's probably none of us here because we're dairy producers. We'll be making our own milk. Undesirable conditions, so things like spoilage isn't necessarily a hazard, right? Again, it depends on the type of spoilage. There may be some molds you might be concerned about, but typically not. Things like insect fragments, hair, filth, well, nobody wants to see those in their products. They're not considered a hazard per the regulation. Though there may be other regulations around them, they're not going to be part of our food safety plan. So talking about biological hazards, potential controls for biological hazards. So again, these are our bacteria, viruses, parasites, molds, right? There are three mechanisms that we're going to use to think about controlling biological hazards. One is we don't want them in our food in the first place. So how do we keep the bacteria, the viruses out of our products, okay? So how do we prevent contamination? That means thinking about where are we sourcing our ingredients. We talked about people earlier. How do we make sure that, right, we have the right hygienic practices in place so that they don't introduce pathogens into our food? And how do we control the environment and clean our equipment to make sure that they don't end up being sources? So if we can control that, keep them from getting into our food in the first place, that's the best mechanism. Now, that's not always possible with our foods, right? Sometimes we're just naturally going to end up having a significant risk of a pathogen making its way in there. And so the next step is, well, then how do we destroy them, right? So how do we kill them? And that's, right, depending on the bacteria, you'll need to think about that. Vegetative, what we call vegetative bacteria, things like Salmonella, Listeria are much easier to kill than, say, something that's a spore. So if you think about, is everyone familiar with CBOT, botulism, right? CBOT is a spore, right? And it requires high heat and high temperature to kill it. So the processing requirements to kill CBOT are quite different than the process requirements to kill something like Salmonella. So depending on the type of product you're making, you need to think about, what are the ways to kill it. So if I'm making canned milk, right, which has a high pH, I need to think about CBOT because it's an enclosed environment. CBOT can grow when there's no oxygen. And so that might be one thing versus, right, regularly pasteurized milk, right? The differences are there. So, and then the last method is, if I can't keep them out of my food, I can't kill them, can I prevent them from growing out to a level where they might present a challenge, right? And so those are things around, right, temperature. I might store my product refrigerated to prevent the bacteria from growing out. Or my product, right, my yogurt will go down to a specific pH that's low enough that I won't be worried about the outgrowth of certain spores. Or my cheese may, right, have a certain water activity that will then, again, prevent Listeria from growing out, and so then that's the way I'm controlling for it. So you need to think about those. Those are the three kind of levers that we can pull to control these biological hazards. And when we talk about biological hazards and pathogens in foods, there's a couple different things to think about. We have things that are called infections and things that are called intoxications. So a foodborne infection is when a bacterial pathogen like Salmonella or E. coli invades the body after you've eaten. So you have a piece of cheese, it has Listeria in it, you eat it, Listeria then makes its way into the body, crosses the gastrointestinal barrier, and then makes you sick, okay? That that bacterial pathogen like Listeria or Salmonella, really, Salmonella E. coli, they don't necessarily need to be able to grow in the food to cause illness. You just need to eat them, right? The level that you may need to eat those organisms may vary, but at the end of the day, if you eat them, right, they're going to cause disease. Same with viruses like hepatitis and norovirus. So there, right, some of our key mechanisms are how do we prevent them from getting into the food in the first place, or how do we kill them, are critical for controlling foodborne infections. Foodborne intoxication is a little bit different. There's a bacterial pathogen, right, and it can only cause a problem when it grows in the food. So this might be something like staph or Bacillus cereus, all right. These organisms that they can be commonly found in foods, but if they grow, if they have an ability to grow, they'll produce a toxin that when you eat it will then make you sick, okay? So if they can't grow in the food, you can control their outgrowth with things like refrigeration or pH or water activity. The bacteria themselves may be actually present in your food, but they're not going to cause disease because they can't grow out to make the toxin. So those are different things to think about. And we're worried about both of those, right? In our foods, right? So like Bacillus cereus is a spore former that's found all over the place. You're going to find it in dairy, right? And as long as you don't give it the conditions to grow, if it's there at low levels, it's not really a big deal. But as soon as you don't accidentally have an unrefrigerated vat or something like that, I've had it happen with ice cream where the temperature on the mix vat went up for a couple hours as they were storing it. Those guys can grow, they produce a toxin, and there's nothing you can do to save the product afterwards. So you got to think about that. So as a little exercise here, thinking about these two potential ingredients that we'd use in our facilities, what might be associated with them? With pasteurized milk, what pathogen might you associate with pasteurized milk? What were you worried about in that process? Yeah, potentially maybe E. coli, but you'd have pasteurization there, right, to help you out, to control that. So that would be something to think about. That's how that might be how you control it. What about like a fresh herb? You're going to do a basil chev. What do you got to worry about there? E. coli too. So how do you control it in the fresh herb? Right? In the milk, right? The name was in there. We had pasteurized milk. So if we had the Salmonella E. coli in our milk, we pasteurize it, we kill it, we package it, we're good. What about with the fresh herb? Well, wash it really good. What is really good, right? How right? So now you got to think about, right, if I'm going to make, right, a product like that, how am I going to deal with that risk for my herbs, right? Because including these kind of things, right, provides innovation and new flavors for consumers, but you've also got to think about then how to control it. So maybe, what might you do? You might find a way to then, quickly heat treat the herb. Maybe some people steam the herbs, right, to potentially eliminate the pathogen without destroying the flavor too much and putting it in their product. Or you might source irradiated herbs instead of fresh herbs. But those are things you need to think about because if you're not controlling, you got to figure out how to control it and think about, because there are real risks associated with those ingredients. And we know they are because we've done a lot of work in the regulatory environment in tracking the issues with recalls and contamination events in the food industry. So it's old now, but back when I started at Unilever, FDA launched this program called the Reportable Food Registry, which requires any company that if they've released a product into interstate commerce and then they find out that there is a food safety risk associated with that product, that they were required, it's before they were required within 48 hours to report it to FDA. And they began looking through that data to understand what were the hazards that were being commonly missed. And so you'll see here, right, when we talk about biological hazards, things like Salmonella and Listeria, monocytogenes, right, they encompass over 50% of the types of recalls that they were seeing. So that was a big focus on biological hazards. And we'll talk about the allergen piece of this a little bit later. Biological hazards are a very big focus, because when you look at it, they are the major cause of the majority of the outbreaks that we see, the majority of the illnesses, hospitalizations, and deaths, which is why we harp on controlling these biological hazards so much, because we don't want to see people getting sick, and we really want to be able to lower these numbers and make sure that we're producing safe product. So again, another little exercise here. Let's think again. These are two different types of finished product. What type of pathogens do I need to think about for a cookie dough ice cream? Might I be thinking about for a cookie dough ice cream? Does anyone here make a cookie dough ice cream or want to make a cookie dough ice cream? Maybe not after this, but salmonella potentially, right? You can think about that in the cookie dough, right? So you got to think about those inclusions, right? When do you add that cookie dough in your process? Before or after pasteurization, right? After, right? So how are you going to control for that, right? I used to, right, I was at Unilever, I used to work for Ben & Jerry's, so let me tell you, I had a lot of fun figuring out different ways to control potential risks that were coming in with inclusions. What about a fruit popsicle? What do you think about that? What was that? Right. You can heat treat it before you freeze it. So they're probably right. There might be some pathogens that come in with the fruit, right? Again, you might think about Salmonella E. coli, but it's a one and done, probably has a low pH, right, on your formulation. So it's the risks, right? You may produce both of these products within your facility, but the risks are different. So again, when you think about doing your hazard analysis and the type of products that you're going to make, you need to think holistically about what the end product looks like, so that you're thinking about what are the challenges are there. So it's 12 o'clock. I'm about to go on to chemical hazards. Everyone running this, should we break for lunch first and then jump back into chemical hazards, and then we'll go from there? Yeah. That's what you want to hear right before you go eat your food, right? We're going to talk about chemical hazards. Hello. You have the opportunity as you're developing your facility to really tackle this hand in hand, which I think is important, right? Because as you start to think about the products that you want to make, the type of equipment that you're going to put in place in that process, you can already start. You start doing the design of your facility, you can do the process flow and start thinking about it, and then continuously updating it and reviewing it as you start production and things like that, and then you'll really hit the ground running, as opposed to trying to walk into it right after having built everything and then figuring it all out and then finding out that you're missing something. So I think that was a great example, but just remember, right, it looks like a lot, but you can get there. So now we'll jump back into to talking about those hazards that Dan mentioned that he was identifying. So we were briefly talking about the biological hazards, so bacteria, viruses, potentially some sort of molds or parasites. The other category of hazards that we need to be thinking about are chemical hazards, right? And these chemical hazards can be there for a multitude of reasons. They could be chemical hazards that are naturally there, right? It's just an inherent part of the food, right? Dairy, right, is an allergen. Dairy protein is an allergen by its nature. Peanut is an allergen by its nature. So it's a chemical hazard, but it's a naturally occurring hazard. We just got to make sure that we have the right controls in place, not necessarily to eliminate it, but to inform people about it. There are other ones like mycotoxins, which we'll talk about maybe in a little bit, which are toxins produced by molds that might come in with certain ingredients like nuts, may come in with certain fruits like apples. There may be chemicals that we're intentionally adding to our food products that when added to our foods are safe, right? But if they're added at the wrong levels, might cause a problem. So you might think of things like, right, we fortify our milk, right, with vitamins, right? And we're putting them in at a level that's safe, but if you were to over-fortify, that might cause a problem. There might be things like, it could be things like preservatives that we may add to our cheese, right, that will help extend the shelf life of the product. But again, if we add it at the wrong level, it could cause a problem. So that might be another source of chemical hazards that we need to think about. So if you're using those, right, you definitely have a chemical hazard that you need to think about. It could be unintentional things that we add, right? We've got to clean our tanks, we've got to clean our environment, right? But if those chemicals find their way, right, they end up staying in the tank at the wrong concentration that's too high, they might end up causing a problem for the product. So you got to make sure that we are using them appropriately. There may be other things like pesticides that come in with grains that we've all got to think about. So we got to sit down and think about those chemical hazards and where they might be coming from. Now, when we talk about naturally occurring ones I've alluded to. Allergens. Does everyone know, before I go to that slide, does anyone know what the top 8 allergens are we need to think about? Anyone want to guess? Oh, that's right. You just go to the book. Great. Yeah, follow along in the book, and you might have the answer. All right, we'll go over here. So the big 8: milk, right? That we're all doing. Eggs, which maybe if you're making French vanilla ice cream, which is my favorite type of vanilla ice cream, you might have eggs in there. Peanuts. You'll see right in a lot of ice creams we have inclusions. Tree nuts. Fish. I don't know anyone making a fish ice cream or a fish cheese yet, but you never know. Could be innovative. Crustaceans, wheat, and soy. So those are the big 8. 90% of the allergic reactions are attributed to those here in the United States. They're different in other countries. And if I recall, they are talking about actually adding sesame to the list of the top 8. So it'll be the big 9 soon. But that hasn't officially come through yet. But that's the word on the street here in the U.S. In other countries, I think Canada, they also have celery, and some places have mustard seed. But here, these are the 8 allergens. So if they are in your facility, you need to be thinking about them and then making sure that you have the appropriate controls in place later on. And again, the reason why we talk so much about allergens is, if you remember, I had that little pie chart earlier. But if you look at allergens as a category completely by itself, right, it is the leading reason that we have recalls of food products, is because there's something around allergens, whether it is mislabeling or cross-contamination. It's a huge issue. And it's a huge issue because we can't remove the allergen from a product if it's already in there. And so for people who suffer from allergies, their only way to stay safe is to avoid that allergen completely, right? So they need to be able to know that whatever food that they're eating, right, that they can stay away from it. And the only way they can do that accurately and safely is if we, as producers, let them know what's in our product. So if we're letting them know, then we're set up for a horrible situation. Does anyone in here, if you don't feel comfortable sharing, you don't have to, but does anyone in here have an allergen? Or know somebody who does? All right, and you can think about how difficult it is to then manage the foods that are coming in. So, and sometimes it can be very serious, right? Like a peanut allergy, some people have anaphylactic shock, which can be deadly, or it could be very simple. And my dad is allergic to peanuts, but all he gets is like a rough, scratchy throat, so he still eats them. But you can see, right, the variability in those choices. So when we talk about causes for allergen recalls, and again, why it was elevated to a required component in the Food Safety Modernization Act, where as opposed, right, in the previous world it was kind of like a prerequisite program. If we look at what are the major reasons for these recalls, wrong label or package, the terminology, so the name of the ingredient wasn't obvious. So for example, we in the dairy world, right, you see whey, and you might think, oh yeah, whey, that's a dairy allergy. But most consumers probably don't make that connection, and so you need to keep a component on there that says contains milk, right? So that might be an example of wrong terminology potentially on a dairy product. No carry through of info from the ingredients. So maybe one of the ingredients you're buying in has an allergen, you forgot to put it on your label. Then comes cross-contact, where people aren't cleaning appropriately, so one allergen from one food product makes it into another one that wasn't supposed to have it, or they've grabbed the wrong ingredient, or things like that. But you see those top 3, those are all around human error, right? And so FDA their mentality here is that by making this a requirement of the legislation and a requirement of the law, that hopefully we can start to eliminate these kind of issues. And we'll see how that. They haven't done a report lately on talking about the number of allergen recalls and whether or not they've gone down over time because of this, but we'll see when they eventually release that report. But that's a key focus, is around eliminating human error when it comes to allergens as a chemical hazard. Another naturally occurring chemical hazard that we might have to deal with is mycotoxins. So again, these are toxins that are sometimes produced by molds when they get to certain levels of growth. And different mycotoxins are associated with different foods. And the thing around mycotoxins is that you could eat a mycotoxin by accident today and you'll be fine. It's that extended exposure to them over time may lead to, they're carcinogenic, so they may lead to issues over time if you keep consuming high levels of these mycotoxins. So we're trying to keep them low in the foods that we consume. And so there are things like aflatoxin, which is very common in peanuts, especially in wet seasons like we're having this year. Dried corn, there's things patulin in fruits like apples. You can see the list there. So if you're using any of these types of foods as ingredients, so Beehive, he left, it would have been interesting to ask him, with coffee, right, you have ochratoxin A, like, you should be thinking about that with the coffee that you're buying and whether or not that needs to be on a specification to make sure that it's under control. So those are the things you need to think about when it comes to naturally occurring toxins that you may not otherwise be able to do much about. Those are the chemicals. We talked a little bit about the unintentional ones and the formulation ones. And then after that, the other big major category of hazards is going to be our physical hazards. So this is all around foreign material that might make its way into our food, whether it's from our processing environment, so things like metal. It could be things that come from the agricultural environment, right? So when we're collecting peanuts, right? Sometimes there's twigs, pieces of wood, stone that might come in with those peanuts that we need to watch out for. It may be also a natural component of the food if you're dealing things in ice cream, if you're dealing with peaches, right? There are the stones, the pits of those peaches, right? Which can cause a problem if they're not removed. So those are all things that you need to think about, and how are they going to be dealt with, or how are they going to be removed either by you or by your supplier. And so again, you need to think through your process on, are these a potential issue for me? And I'll say for the dairies, right, we have a lot of metal contact in some of the pieces of our equipment, so we need to be mindful of the points in our process that might introduce broken pieces of metal, like off the knives that we're using to cut the cheese, or from certain pumps. So think about that. And again, I mentioned, depending on the types of ingredients, if you're making ice creams or things like that, what might be coming in with those inclusions, because those can cause a potential issue, and we need to be aware of them and then put a plan in place. So we've talked about these three classes of hazards. So how do we find out more information, or how do we learn more about the type of hazards that we should be thinking about or potential problems in our facility? And this all depends on where you are in your process and whether or not you've been up and running or not. But when you talk about potential issues within your facility, you can talk to your employees, especially like when it's around equipment concerns. Are there pieces of equipment that are harder to clean than others that I need to pay a particular focus on so they don't become a source of a biological hazard? You may reach out to consultants or university specialists like you guys are doing today, right, to talk about, well, what are some of the hazards associated with my food and my process? Obviously, I mentioned things like FDA, that little hazard guide that they have is an important resource to go look at. Trade associations, like, I guess they're not quite a trade association, but again, American Cheese Society has a lot of information on their website, as does IDFA, where you can find information around this. Also, there's information on the Innovation Center for U.S. Dairy's website around environmental controls. So these are all resources available to you to help you more thoroughly evaluate and identify the hazards that are part of your process and your products. And again, this is just an example of some of the publications out there. There's that Hazard Analysis and Preventative Controls for Human Foods training curriculum, which is what these books are based on. But if you also go to the Food Safety Preventative Controls Alliance, FSPCA, they have a really big book. Some of you may have that. It's a great book to keep by the side of your bed. But you can download a PDF version of that and flip through it and read it and use it as a resource. FDA has a lot of guidance documents on there to read through. And occasionally, I think for most people, you're not going to need to go through peer-reviewed literature and things like that. But again, things that are provided by your local trade associations will be helpful. And I'm sure even here, right, with Dairy West, you're going to have links to resources for people to access. So, and those are, again, some of the websites. Do not use Wikipedia. So these are some websites that you should consider using. Don't use Wikipedia or some strange Reddit site or something like that. look for some validated and verified websites that have been put up there by public health professionals or researchers or things like that. So FSPCA, FDA, CDC, those all might be relevant places to look for information. So, and let's talk a little bit about this, but as a quick little exercise, let's talk about what's a biological hazard that's associated with our dairy products. Just one, two. Does anyone remember from before lunch? Unrefrigerated, because of why? What might grow there? Bacteria, right? The bacteria will cause higher acid, but yeah, a bad bacteria, a pathogen like listeria might grow out on you, right? Yeah, or if it's pasteurized milk, right, maybe it'll be Bacillus cereus that'll grow out and produce a toxin. That's a biological hazard. What's a chemical hazard that we just talked about that might be associated with milk that I need to think about? Or my cheese? Chlorate, right? So our cleaning chemicals, exactly, could be an unintentional chemical that could make it into our product. So that's exactly a chemical hazard we need to think about. Should be on your list for consideration. Any other ones? I'll harp on it again, right? Remember, milk is a dairy, so we're going to have some controls around the dairy allergen. And there might be things like the vitamins in our milk. And then lastly, what might be a physical hazard that I encounter in my environment that I need to pay attention to for dairy? Did I hear metal? I think I heard someone say metal, right? So, louder? Oh, wood chips. Hair, but is it a physical hazard, hair? If I eat hair, well, yeah, I might gag and I may not want to see it in the product, but it won't physically hurt me, right? So yeah, and right, so it might be something like a hard piece of wood or right, a piece of plastic or something like that. So that's a good point, right? It depends on what it is. So there may be foreign objects that make their way into our products that we don't want. We're going to get a ton of consumer complaints about, but they may not be then physical hazards, right? You might imagine like a piece of a glove, right, that someone's wearing gets ripped while they're in the processing environment. Not great. We don't want it in the product, but it wouldn't be a physical hazard. If they had a watch, right, or a piece of jewelry, that broke off and made its way into the product, that would be a physical hazard that we might need to worry about, which is why for something like that, we have our GMPs around, right, things like wearing jewelry and stuff like that Dan showed earlier. So there are ways to control for that. So yes, so those are the three classes of hazards that we're going to need to be thinking about as we now walk through to do our hazard analysis. So we're going to go systematically through, and we're going to go through each of our ingredients and each of our processing steps and ask ourselves, is there a hazard that falls into one of these three categories that's reasonably likely to occur, and if so, what I'm going to do about it. So how does that whole process look? And it leads to that large document that Dan just showed us. So here we'll step into, well, before I go on, any questions around the classes of hazards or identifying them or things like that? No. And you'll see, usually it's pretty stable. This past 2 years have been an interesting year. I mean, what was it now? March and a half. 2 Marches ago, when COVID hit, I can tell you my email box was getting flooded with dairy producers around the country asking, should I be worried about the coronavirus, and what in my processes controlling it? And we sat down, we talked about it, right? It's eliminated by pasteurization, and right, it's not readily transmitted through foods. But everyone sat down, everyone that was in charge of a food safety plan sat down and thought about it, and then evaluated whether or not it was a risk for our dairy products. Turned out not to be, but that's kind of an example of where sometimes things do change. In this modern world, things change much more quickly than we're used to. So, all right, preparing for our hazard analysis. Now we've kind of got an understanding of what our hazards are. How do we actually go through and perform this hazard analysis? Again, I mentioned, right, it is initially a straightforward process, but it's one that's always folding back on itself as we learn about new hazards. We change the type of products that we make. We change our processes. It always needs to be constantly evaluated. So what are the vocabulary and things we need to know for starting off this hazard analysis? So first is, what are our preliminary steps? So this is gathering what the regulation would call Optional or informal actions should be performed prior to the hazard analysis in order to facilitate the process of the food safety plan. So this, again, includes things like understanding what are the parameters of the products that I make, what is the process flow within my facility, how is my facility laid out, what is the area that it's in. These all are factors that could influence our hazard analysis, right? Whether you're an on-farm processor or whether or not your cheese facility is going to be very physically separated from your dairy operation. Those are all things to think about. You're going to need to think about your prerequisite programs. Again, these are things like our good manufacturing practices that are the foundation for the food safety plan and the food safety system overall. We're going to identify, this terminology now is preventive controls. Dan mentioned HACCP before. Right, it's not a term that we're using anymore in the food safety plan world. We're going to talk about preventive controls, not CCPs, and not, instead of HACCP, it's a food safety plan. And our food safety plan is the written set of procedures for monitoring, verifying, and the corrective actions that we have for our preventive controls in our facility. So what are the first preliminary steps that we're initially going to do? We're going to get a team, right? Because it's really hard, for any one of us, right, to have enough knowledge to understand all the potential risks within the facility and all the steps that are going on within our facility in the production of our products. So bring a team. It could be an internal team. It could be a team where you liaise with outside consultants, with university experts. Call us. We're always here as a resource. Pull together a team. Sit down and describe what are the products you're making, which cheeses, what are their pHs, how are they being made, how are you doing distribution? Are you going direct to consumer, or are you using somebody else to help you distribute the product? Who is going to be eating your product? Because depending on that, that may impact the level of risk that you may be thinking about. So maybe we talked about innovating spaces and niches, right? Maybe you're deciding to develop cheeses that are targeted to young toddlers, right? To help them with nutrition, right? Because dairy is the greatest nutrient source there. But there are then risks, right, associated with toddlers that they're more susceptible to certain types of infections. So that will change the way you think about your hazard analysis. So think about that. Then you're going to want to develop a flow diagram of your process and how you're going to make your products. So you can look through each step to see if there's a potential risk that's introduced there. And then the last thing you're going to do is, after you develop that flow diagram, is go back and verify that it is actually the way the process is set out. I mean, sometimes, right, you have, especially when you're in the initial planning phases, you've got these blueprints of how the facility is going to look and how the piping's done and where the equipment is positioned. And then the construction guys, when they get through doing what is actually convenient for them, it may actually look different than what you had down planned on the piece of paper. So make sure you verify the flow diagram. And even later on, when you're in production, right, sometimes changes happen on the processing floor that change the way you thought things were flowing. So verification of the flow diagram is an important preliminary step. When developing your team, you saw Dan had something like this, right? You can have just a very simple template where you keep track of who is involved as part of your food safety team, what their roles are, what type of training or background do they bring as far as food safety, what part of the food safety plan are they responsible for. Maybe they're responsible for reviewing ingredients or doing the sanitation controls. And then we talk a lot about documentation and keeping track of things. What's the date that they actually did that kind of work, just to help you cover that. And you might also do a facility overview. Again, Dan had something like this, where you talk about your company, where are you located, what its address. Again, your good food safety plan is for a given facility. So if you end up having multiple facilities, you're going to have a separate food safety plan for each one. Talk about your business, how big it is, how many employees are there, how was it built, what are the materials, are there any things, right? Because that gives you a foundation for showing whether or not, right, you have any risk potentially associated with your overall facility. And what are your major pieces of processing equipment. Now, in the back of the template, here, let me come over here really quick. And it always depends on your facility. I'm going to grab this really quick. There is an example in the back of the template book. There is this food safety plan for pepper jack cheese making. which just has some of these components in there. You can always flip through it and look. Again, I wouldn't use it as a verbatim food safety plan, but it's a good example of some of the detail they put in there. It was developed by the University of Wisconsin in conjunction with a group of cheesemakers up there, and there's a digital copy available on the safecheesemaking.com website, but it's at least a good resource to kind of help you think about, well, what level of detail do I actually need to write, right? Because someone asks you, hey, write something. Well, how much? That'll give you at least an example. When we're talking about then in our preliminary steps, describing our products, right? What type of information should I think about including in there? Again, you don't need to write a book. You just need to provide enough information that you're sure that you're capturing the critical components of that product. So what are the names of the products, right? We saw that list from Dan. He had a list of each of the different types of cheeses. Are there anything relevant about those cheeses that might impact the food safety? So again, the pH, we talked about pH, water activity. Are there any preservatives that might help me out? Include those kind of things. What are the ingredients? How is it packaged? How long do I expect it to be out in market? And how do I need to store and distribute it, right? So that it's all contained in one place for easy reference. And then you can use that later on when you actually go through the steps of your hazard analysis. I talked earlier about intended uses and consumers, so think about that, because that can always change some of your risks. It's not quite a dairy example, but I'll just give you an example of where there might be unintended uses. So at Unilever, right, we made a lot of dry soup mixes, and we made an onion soup, right, mix, which was great, delicious. It turned out that our marketing people had put out recipes to take that onion soup mix, which you're supposed to take home and then boil, right, in water. Then you inactivate any pathogens in there. They were recommending to add it to sour cream to make a French onion soup mix, right? Which, right, could taste delicious, but now we no longer had a heat step, right, to control for any potential pathogens in the spices that were in that onion soup dry mix. So we had to change the way we made that onion soup mix to control for those pathogens. So it was an unintended consequence from when we developed the product to then how it was actually being used. And sometimes, right, it may not even involve your marketing people. If you end up finding out that there's a significant group of consumers using your product in a way you hadn't originally intended but are doing it anyways, that might change the way you think about your products. So that's just an example. Yep.
Is there a liability if the consumers start using it but your instructions?
Yeah. Ask the cookie dough guys, right, who sell raw cookie dough, right? You still get a recall, right, because the pathogen's in there. And so even though the instructions on raw cookie dough say, please, you need to cook this, if they tested and they find E. coli in there, they got a recall and you're liable. So, yep, because enough people are doing it. So, again, thinking about at-risk populations, we may not be doing this here, but again, some of our dairy products do end up going to high-risk populations, so those companies have to think about it when you're doing infant formula and things like that. Just be cognizant. I had a scare in Canada many years ago where a company had a challenge with listeria in their ice cream. And it also turned out that the ice cream that they were producing was specifically being sent to a nursing home, right? So, right, those are all the, right, you got to think about who am I targeting to sell my product to, and does that mean I have an extra set of risks, right? Because sure, there's great volumes going through the nursing home, but then you got to be extra careful with what you're doing. So be cognizant. Again, an example of how I might fill out my product description form, and you can always look at the ones in the back of the book too to kind of get an example. You'd fill it out with a template like this, where you'd list your product name, and then you'd kind of break out all those specific information that you'd want to have. What are its characteristics? What ingredients are in it? Is there any specific labeling? You're going to have things like allergen labeling on there. How long does it last? Does it need to be stored refrigerated or not? These are all important things to keep here and document so you can reference them later. And so again, what might something look like? This is for the pepper jack cheese, and here you can kind of see the level. This is pepper jack cheese, is a pasteurized semi-soft natural cheese with added peppers, right? Product supports limited growth of pathogens in early aging, but because of it's got a high pH, 5 to 5.4, there is some inhibition from the cultures and enzyme activity and salt over time. So, and then their diced peppers are in brine that also helps out. And they talk about their ingredients: milk, pepper, salt, cultures, enzymes, calcium, what the packaging is, their intended use, general use. It's a ready-to-eat product for consumers, so there's going to be no secondary cooking, and what's their shelf life, and their labeling instructions. So, and you'll do that, right, for the number of cheeses that you have in there. And then another component that we talked about that you need to have in place to do an effective hazard analysis is this flow diagram, right? And so you're going to want to walk through all the processing steps that your product goes through, right? So raw milk receiving, right? We'll have an example here in just a second. And then potentially to help you understand it, it'll help to have a written description. So here's an example of that pepper jack cheese and how they broke it out, right? They have ambient receiving, right? For their ambient ingredients, they have raw milk intake. They've got receiving for their packaging. So you can see the level of, what level are they breaking things out at, right? They've got, for the raw milk intake, antibiotic screening, filtration, raw milk storage. Then they've got that the pasteurization step, their process control. It goes to their cheese vat. And you see here, they don't talk about every specific step in their cheese vat, in their process flow. They just talk overall, this is the cheese vat. And what they'll do is we talk about the process description. That would be a separate document that might then talk about what's actually going on in the cheese vat. But you don't need to break out every step of your cheese make in this flow diagram. Like, you don't need to be like, cheese vat, add rennet, cheese vat, right, cut my cheese. It can be a little simpler here on the process flow diagram to make it a document that you can walk through easily, okay? And then lastly, just the reminder, please go back and verify that your flow diagram is actually reflective of what's going on in your processing environment, because you can find surprises. And then this slide we don't need. So that's our preliminary steps, right, before we actually dive into the hazard analysis. Again, the regulation calls those optional, but without that foundation, it is really hard to do an adequate hazard analysis. And so what are we going to do through this hazard analysis? Now we're going to methodically walk through. We're going to list those processing steps, right, which we've kind of outlined in our process flow diagram and through our process descriptions. We're going to go through our ingredients, and we're going to ask ourselves at each point in that process, are there any known or reasonably foreseeable food safety hazards, whether those are biological hazards, chemical hazards, or physical hazards? And then we'll decide, does it require preventative control, right? Is that severe enough or probable enough to be an issue if I'm not controlling it? And you, depending on how you do this, you can kind of gauge it yourself. You could use a matrix like what Dan showed, where you actually do some numerical calculations. That part is up to you, but you need to have some sort of thought process on whether or not it is a severe risk and how likely it is to happen, right? Justify your decision in writing, and then identify if there's a hazard there that needs to control, what that preventative control is. Now, the way that template looks, there are various formats for that. This is an example of a template that's used by FSPCA. And it's a little different, I think, than the one that Dan shows, but there are multiple versions out there where you can see right in this left-hand column, I'm going to list my ingredient or the processing step that I'm going through, and then I'll go through and ask myself, is there a biological, B, C, chemical or physical hazard? And then I'll ask myself the next question, do any potential food safety hazards require preventive control, yes or no, why? And then a little brief statement on what type of control is that, and then we'll talk a little bit about whether or not it's applied at that step. Again, I mentioned there are multiple formats out there, so you can see there are different ways to handle it here. Let's pull this up. You can see right here, they do a little bit more around, some people will sit down and actually try to quantify the likelihood of that occurrence happening, and then the severity of the health effect. So if you decide to do that, you can, but you don't have to, right? You can do something just like this where, you know, did you decide whether or not it was a relatively likely or foreseeable hazard? And then as we talked about, right, we're not talking about all hazards because there are a ton of hazards out there. What we're really focused on is known or reasonably foreseeable hazards, right, for our products. So, right, radiation, you may have seen it listed a little bit on there as a potential chemical hazard. Is radiation, it's a hazard, right? Is it likely for any of you to have a radiation issue in your food products? Anyone here? Right, I'm saying right, so it's a hazard, but it's not a likely foreseeable hazard for you now. Maybe if you were, farming right outside of a nuclear power plant, or again, a lot of these regulations were written around the time that we had the Fukuyama disaster in Japan, where a lot of seafood got contaminated, so that might be a reason where it might be foreseeable, but in most of our cases, it's not. So focus on the foreseeable hazards or known hazards, right? Again, if it's listed in something like the FDA hazard guide, it should be then listed on your hazard analysis. Now, how might we control for these hazards? Because that's what we're going to put in our hazard analysis, and we're going to dive into these later this afternoon. But there's, again, going to be 4 categories of preventive controls that we're going to use. Process preventive controls, which are really going to be around, eliminating a potential hazard. Food allergen controls, which are going to be focused around things like allergen labeling and identifying those allergens for our consumers. We'll have sanitation preventive controls, which are around cleaning our equipment and our environment. And then supply chain programs, if there are ingredients that are coming into our facility that we don't have a process control step for, but that our suppliers are controlling for. So we'll talk more about those in later chapters. So again, when we're going through our hazard analysis, think about the formulation of our food, what ingredients are going into it, the hygienic design of our equipment, which is why it's so important to get that right up front, because it costs a lot of money to correct those equipment deficiencies once they're already in place. Think about, again, how you're going to distribute, how you're going to store. Think about the environment of your facility. I mean, I talk to people like Steve and things like that about, what is the material that I should be using for the floors? What material should I be using for the walls? All those kind of things to make sure you put the right pieces in place so you don't have extra hazards that you have to deal with later on. And how do I evaluate the severity of the foods? There's that matrix that Dan showed, but a lot of times it's about talking to public health officials or looking at documentation to understand if somebody were to ingest listeria, how bad would it be, right? And with listeria, it'd be pretty bad. As opposed to say, like a mycotoxin is a chemical hazard that we need to be thinking about, but its severity is not as great, right? Somebody's not going to become immediately sick if they eat that. So the way you control for that will be different for something like a mycotoxin versus something like a pathogen that's going to cause immediate illness. And then thinking about your consumers and how susceptible or not they are to a particular thing. And then evaluating the likelihood of occurrence, History, is a great teacher. So if there's a history of an issue with a certain hazard, again, listeria coming in from the environment, then you know that is something that we're going to have to think about. If we start to see a bunch of recalls, so maybe we are using an herb in our product and we haven't had any problems, but all of a sudden we start seeing in the news that, basil, is going through a ton of recalls from other companies. And you're like, well, I use basil too. Well, then maybe you need to go back and then reconsider whether or not that has changed the likelihood of that pathogen in that product. And so again, a lot of these are also resources that we would have evaluated to help us develop the plan in the first place. Some examples of the types of preventive controls that we would then put in place to control a specific hazard. For our biological hazards, we might have a heat step like cooking or pasteurization that's going to kill things like Listeria, Salmonella, E. coli. We might have something like refrigerated storage that might then prevent the outgrowth of spores, so we're keeping it cold over time. If we're buying an ingredient like peanut butter that we might be incorporating into our ice cream, you might then want to make sure you might have a supply chain control because you're not going to do anything to that peanut butter, but you're going to want to make sure that the company that you're buying the peanut butter from has a heat step to kill things like salmonella that might be in that peanut butter so that you don't have to deal with it. Or you might have something like sanitation controls to prevent recontamination from the environment. So after we've pasteurized our milk, and now we have this wonderful, nutritious milk sitting in our vat. We want to make sure that we have the procedures and processes in place to make sure that any listeria in the environment doesn't find its way back into that milk and then cause a problem. For chemical hazards, we might again have, we'll have things like labeling to ensure, that our labels have the right information on there for the consumers. We might have a supply chain program around making sure then that if our our ingredient supplier has an allergen in there that it's declared on their products. And then obviously we're going to have cleaning and sanitation controls to make sure that if we have a unique allergen, that it doesn't, like, that we can clean our equipment sufficiently so that if we run a different product through there, that it doesn't pick up that allergen. And then for physical hazards, these are, the process controls for these are a little different. You might have something like metal detection. You might have filters in place, like in the fluid milk, to catch anything that might be in there. But you can also do things like visual inspection, and making sure that the equipment is still intact after you've done a day of running and that any metal didn't make its way into the product. And so, again, here's an example of the flow diagram for the pepper jack cheese and how we might go through it. And so you just kind of walk through, right? That is the hazard analysis. And we're not going to go through each of those, that whole process. Usually we'd break out in a coaching session, but you're going to go through and ask yourself each of those questions for each of the processing steps and ingredients. So, any questions? Smoke. Yeah, so if smoke, let's think it through. So if smoke, how would it impact my product? Yeah. Yeah. So for us, air quality might be important for us right now, right? But it's not impacting the product in a way that if I were to then eat my cheese that was made with the smoke in the air, right, that it would impact anybody's health, right? At that step. So yes. Yeah, no, it's a good, right? But that's the point, right? There's a hazard out there. Now let's ask if it's a reasonably likely to occur hazard or not. And if it's not, then we don't have to worry. Now, if, say that was smoke from like a iron refinery plant or something like that, right? That had heavy metals that were then dropping onto the field, and I collect those vegetables and use them in my product, right? Now you have the potential for some sort of chemical contaminant, and you might be concerned about that, right? So it depends on where you are and what's going on, what type of smoke, what type of pollution is there that might impact your product. And that will vary by location. But that's exactly the type of process that you need to go through to check off. Yep. No. Other questions around the hazard analysis? And so there's, again, an example of that hazard analysis in the appendix of that template book for the pepper jack cheese, which is just kind of a loose reference. I wouldn't use it as gospel for everything, but it kind of gives you an idea of how you might do that and what the process controls and hazard analysis might look like. So other than that, then I think we're going to move on to our first set of controls for the afternoon. Does anyone need a little breather, or we're going to keep running? I know it's a lot of information, so. All right, let's keep, because there's a break at 2:30, right? Isn't there? All right, then we'll keep running until then.
All right, thanks, Sam. All right, now you get to listen to a different voice read things to you, so that was it. And it's after lunch. That's where I get stuck to. So you all can wake up. I might ask some questions, and you're being super timid with your answers. You can like yell them out really loud. There's a 50-50 chance you're going to be right, so just flip the coin and we'll go with it, okay? All right, process control. So Sam just went through how to identify the hazards that are in your processing in your dairy production. Now we're going to talk about the controls to implement to control those hazards. So the first one we're going to talk about is how to control your making process. So as you're making cheese, how do you control those things? So we're going to talk about the principles and the process preventative controls, including the parameters you're going to use and values for the control, how you monitor the control, and the corrective actions if you don't hit that parameter. So in your booklet, there's the blank process control form, and this is how if you're doing this, you would have already filled in your hazard box, right? You've identified a hazard and filled it in the box. If we're doing dairy, what's the number one hazard? It's been talked about several times. It's your main ingredient. Yell it out real loud, come on. Milk, all right. So you've identified the incoming raw milk as a hazard, and now we're going to implement a control. In dairy, what is the typical control for incoming milk? Pasteurization, right. So you're doing some combination of pasteurization. If you're a facility that's got a high throughput pasteurizer or a high temperature short time, you might be doing that. If you're smaller, you might be doing a batch pasteurization over a longer period of time. So we would fill in that box, the process control is pasteurization, right? So this one is the pepper jack cheese. So we've said, okay, milk pasteurization, the hazard is incoming raw milk. The potential hazard is there might be vegetative pathogens in that raw milk. And how are we going to control it? Well, we're going to use pasteurization to control that. Right there. So we filled in HTST. You have a fancy pasteurizer, you're going to use it. So in that process control, we're going to define critical limits. And the definition, which I'm going to read the whole thing to you, says the maximum or minimum value or combination of values, it doesn't have to typically just be one in a process, to which any biological, chemical, or physical parameter must be controlled to significantly minimize or prevent the hazard, which requires a process control. And there's a lot of guides you can go look at for different process controls and what you ought to set those limits at. The FDA has some hazard guides, the food code, the PMO, which is a big one. Remember, get the book. It also helps you sleep too, just like the food safety manual. There's other regulatory guidelines depending on the state you live in. They might have state or local regulations tied to some of these process controls. If it's not a defined one, you can go talk to the experts, either internally or externally. Those can be people who specialize in those processes, university food scientists, microbiologists, or other consultants. There's been a lot of talk about finding people to help with those. If you can also go look at conduct scientific studies, so you can run experiments to determine what critical limits you've got to set for that process control. You can pay people to do a third-party challenge study. There's contracts labs. Universities will run them for you sometime. If you're inclined to do it, you can go dig around in the literature, scientific literature, in peer-reviewed journals, food science, microbiology textbooks and different things, and usually somebody's done some kind of testing on a process control, and you can find what kind of limits you need to set. What about for pasteurization? Where do you find those? PMO, good. These guys over here have been whispering the right answers the whole time in my ear. I'm the only one that could hear them, so good. Critical limit considerations. If you don't meet that critical limit, then the hazard hasn't been controlled necessarily. And the potential is that you've now produced a product that's not safe to sell or consume. So when you're setting these critical limits, you got to set them so that you can achieve them. If your critical limit, say your step is a cooking step, you're making a product that runs through an oven, and you say it has to reach 170 internal temperatures that comes out of that, and you have a hard time hitting that, then the critical limit needs to be reevaluated, or the process. And there can be a lot of different options for controlling a particular hazard. Sometimes heat treatment isn't the only option for controlling something that you've identified. It could be a combination of other things like the amount of water in the food or moisture, the water activity, or the pH. And usually when you're selecting these, the best option is often driven by practicality, how easy it is to implement it, and it can be by experience too. So maybe you've had a lot of experience in things that are problematic. Okay, so here's some critical limit examples. Here's one for a battered product. You're worried about Staphylococcus aureus growing and producing toxins. Sam talked about food infections and food intoxications. This would be an intoxication. So as the batter sits there at the right temperature, you have a potential for the staph to grow out. It makes a toxin and can make you sick even after it's been cooked subsequently. And so your critical limit would be that hydrated batter does not exceed 50 degrees Fahrenheit for more than 12 hours. So it's a temperature. The batter's got to stay cooler. Okay. Stay cool so that organism can't grow out. Another potential critical limit, you're making a chop product. The hazard is, in that chopper, the blades breaking and you get metal inclusions in your food, your control point can be a metal detector. And you can have a critical limit of either no detectable metal through your metal detector, or you can control it by visually inspecting your equipment afterwards to make sure that the blades didn't break and end up in your food. You're making a high water activity, ready to eat food. You're worried about pathogen growth. So this could be like a ready to eat meat product. How are you going to control that pathogen growth over time? Well, you're going to use cold storage. And the cold storage, your critical limit is it can't exceed 41 degrees Fahrenheit. And that's how you control that potential hazard. Yeah, fresh cheeses. So what would be a high moisture fresh cheese? Come on, dairy guys. I know you know because we talked about one. Like what? Like queso fresco. So you've got that fresh Mexican cheese. It's a high moisture, typically not a very low pH cheese. It becomes problematic, right? So it needs to be kept cold to not allow pathogens to grow out. Okay. Critical limit, batch process. So I think this is this example is eggs, an egg product. You're making like an omelet product. So you've identified that the hazard is potentially vegetative cells from salmonella. And you've decided your critical control point is cooking, and you've set the critical limit. You want a minimum product temperature coming out of the oven of 158 degrees Fahrenheit. And how you apply it is in an individual cook in a batch process. So like vat pasteurization. What's the parameters for vat pasteurization that's different from HTST? You guys know? The dairymen are shaking their heads because they don't have to pasteurize. They just put it on a truck. What? You have to cook it, so it's typically a lower temperature, like 140 for a longer time, 30 minutes. 145, yeah. And you've got to monitor, good, you've got to monitor the headspace above it to maintain a certain temperature, because the definition of pasteurizing a milk is to hit every particle of milk at that temperature for that prescribed time point. And to reach that temperature, you usually have to heat the headspace, or you have to heat your milk at a higher temperature for batch pasteurization. Yeah. Okay. Continuous process. Does anybody do continuous processes in here? Any of you other cheese makers? You're probably mostly all batch processes, right? So a continuous process would be like you're extruding an egg product into an oven conveyor, and it cooks as it goes through the thing, and then it comes off and you cut a piece off and package it, or however you're going to do it. And so the way they're controlling this is the critical limit set, or the temperature of the oven, how fast the belt is going, and the amount of batter or egg or whatever that's going in the pan in the continuous process. And they validated, typically if you're going to do a continuous process and set those type of parameters, you validated those three parameters will give you a final cook temperature that you're looking for. So HTST, what are the parameters? 4? It's 15 seconds, right? Yep. And so typically in an HTST, those are the parameters. You're hitting that temperature for that time in the hold, and I think we'll talk about it a little bit. Yeah, go ahead.
There is just temperature. We're talking about temperature of time, right? But there is also, even though it's controlled for us, right? There's flow rate, right? That's how you're controlling the time. The flow rate, right? Your timing pump. Oh yeah. And so it ends up getting locked for us, fortunately, to very low, right, by our perspective. But that is technically another component, right, of that critical control. We need to have the right flow. Right, exactly.
Yep.
For the HGS, you need to make sure your flow rate is correct to achieve the time, right?
Yep, they come and they mark that, and then they put a little stamp on there so you can't open and mess with it, which is lucky for the HTST. It makes it simpler for you, right? All right, the pepper jack example, we've kind of talked about this. If you're filling out your form, looking at your cheese, you've identified a hazard. It's biological, potential pathogenic organisms. We've identified the process control. We're going to use milk pasteurization. We've set the critical limits for this. It's set for us, right? It's in the PMO. This is what we have to hit. Just incidentally, this is my favorite question I like to ask my students. What are these parameters set for? Does anybody know? Why is it at that time and that temperature? Anybody ever been exposed to this? Originally, what was it? Eric, you can answer. I see you smiling. That's what it is now, right? It's Q fever, so Coxiella burnetii. It used to be a slightly lower temperature parameter, and that was to kill Mycobacterium tuberculosis. So they set it for the most heat-resistant pathogen that you find in milk, and it happens to be Coxiella. You're right. That's why the government defines that, because they've done a lot of work on it for a long time. Okay, the definition of to monitor, you're going to conduct a planned sequence of observations or measurements to assess whether control measures are operating as intended. So what's the purpose of doing this? You want to track the operation. You want to be able to identify trends, which is important, right? If you're going throughout the day and you're seeing your trends going up and down or slowly going up over time towards your critical limit, then you might need to trigger an adjustment in how you're doing things. In a pasteurizer, who does that? Does the pasteurizer do it itself? Yeah, usually we'll heat up those transfer plates hotter to maintain that outcoming temperature, right? So if you're getting fouling on your plates over time, you're going to have to apply more heat to the system to reach that critical limit and that hold time. You're going to monitor also to identify when there's a loss of control, and this is when you have a deviation from the critical limits. And then you want to be able to have written documentation to verify that the process is under control, that you're controlling the hazard. So the elements of monitoring, you want to identify what you're going to monitor, how you're going to monitor it, how often you're going to check, and who's going to do that. So what are you going to monitor? Well, in cheese making, we use temperature a lot, right? We monitor temperature. Time can be a component, like Sam was talking about. Flow rate, so how fast the milk's moving through things. Some things you might not think about are how much acid you're putting in your product. So if you're adding an acid, the pH. So in cheese making, this is an important one, right? You have parameters you're trying to hit in your pH as you're going through that cheese make. Water activity, so this can be, say you're making jerky and you want to have a certain water activity in your final product. Chemical concentration can be like preservatives that you're adding to the product. And there's a lot of other ones you can go through here and identify. Then once you've identified what you're going to use to monitor it, then you're going to decide how you're going to monitor it. So say it's a temperature. You're going to monitor that with a calibrated thermometer. Why does it need to be calibrated? There's a lot. I see mouths moving. I can't hear anything. Why? So you got to make sure that that temperature you're monitoring is accurate. So you got to have a calibrated thermometer, and they're going to care if they come in and do an audit whether you've calibrated that thermometer or not, right? And calibration is really simple. If you remember back to if you ever took a chemistry class, sometimes the calibration, all you need to do is put it in some ice water and make sure it hits 0 in the calibration. pH meter. So if you're making cheese, you're going to have one of these in your facility. Do all you guys that are making cheese right now all have a pH meter in your facility? Yep, they're all nodding their heads or raising their hand. You measure pH throughout the process. Go ahead, Eric. Make sure it turns on. That's right. Also, you have to calibrate your pH monitor. You two that raise your hand, you calibrate every time you go to use it, right? Yep. And it's the same principle. You want to make sure that pH value you're reading is actually the pH value. Another ones can be a calibrated chart recorder. So you guys that have HTSTs, that's what's hooked to that, right? Your pasteurizer is a calibrated chart recorder. You can have inline analyzers. These become more complicated, more expensive. They're usually seen at bigger facilities. Sometimes it'll be a pH monitor. Sometimes it'll be like an IR monitor to monitor like solids or other things in there. You can get real-time laboratory analysis. This would be like more pH would be one that considered what? Oh yeah, TA would be one. You can do other ones that are quick and fast, like say you have a machine that can read the amount of protein, or water activity. So water activity is like something that will take a couple minutes if you have the right machinery. And then another one can be visual checks of the process.
I just go here for like the importance on real time is like sometimes people talk about, oh, I'll just test it for bacteria, right? I'm worried about salmonella. I'll test it for salmonella, but it'll take you days, right, to get back your salmonella results. There's no way you can use it as an effective control to respond to in your process. So it needs to be something that gives you a result immediately, so you know if there's a deviation. So the emphasis on it.
Yeah, but we'd be millionaires if we could figure out a real-time microbiological test that you could use. So it's because in microbiology testing, and we might get into this environmental monitoring, but there's three aspects to the test. It's the cost, the time, and the accuracy, and you can only have two of those. So it either costs a lot and it's fast and accurate, or it's accurate and it takes a long time and costs less. So you can do some things, but they become prohibitive for a lot of people to use. Yeah, it's all right. You can use it as a parameter. pH is a good one, and we'll probably talk about that as we go through here. So how are you monitoring conducted? So it depends on the control. Oh wait, I already did this one. Continuous monitoring considerations. So it's preferred. It'd be nice if you can continuously monitor it, like your pasteurizer, your HTST. You've got a chart recorder. You can pinpoint when there's a deviation. This would be like a temperature recording chart. This can also be used in like your cold storage. So you can have a chart recorder in your cold storage area to verify that you're holding that high moisture cheese at the right temperature. A metal detector, those are continuously monitored. They're usually put on a line. As your product goes down the line, it'll identify a potential, it'll detect the metal in there. I'm not sure what a dud detector is. This is...
It's sometimes for canned beverages, and they'll check to see whether or not the caps are.
Oh, okay. So that's sealed correctly? Yeah, okay. I'm not a beverage person, so I don't know that one. You can have an inline pH probe. We kind of talked about this. A barcode scanner, so as your product comes off the line. And then a vision system for foreign material. And these are really sweet if you've ever seen one running. So like a potato chip factory, they might have a conveyor belt that pushes it over a gap in the belt. And they have a really sophisticated monitoring that'll check, and if it sees something it thinks isn't a potato chip, it'll blow air and blow that out of the line as it goes through. So, and this visual system one for foreign material, in my previous life, they used to have x-ray machines to look for foreign material on some of their lines. Non-continuous monitoring considerations, and this is actually probably mostly what artisanal cheesemakers are going to be using, because the continuous ones are expensive and out of scope for the volume of stuff you're making. So the frequency of the non-continuous monitoring, you want to define that. How much does the process normally vary? So if you're saying temperature is your control parameter, you should maybe at the beginning take more samples so you know the variability of your process throughout the day. You want to know how close the normal value is to the critical limit that you've set. And then how much product is at risk between your monitoring points. So for you, it might be less, right? For a big facility, if they only monitored once an hour, they might produce 10,000 pounds of cheese between that hour point, and there's more product at risk as you're going through. Some non-continuous monitoring examples are temperature checks, water activity checks. If you're using an antimicrobial chemical, levels in like produce wash water. So you take your strip and check the concentration of the chemical in there. I would add in here pH 2 for certain processes. So if you're making cheese, we talked about Staphylococcus aureus. There might be some processes in there where you're in a dangerous temperature for a certain amount of time, and you want to make sure that your product has hit the right pH before it goes into that phase, like cheddaring or something, and it becomes less critical control point there. Okay, exception records, you generate these when you have not met your critical limit. So some examples would be like your cooler has gone below or above the set limit, or your x-rays responded to a foreign material in there. And typically these are linked to an alarm or something in a continuous mode. Typically with an x-ray, it's actually really, really neat. It's on a fast line, and if it hits the x-ray and triggers it, it actually just kicks it into a bin, and it doesn't even go down the line. You have to generate a record for this every time an exception happens, and your exception record system has to be validated. And if you see, if you ever go in a big facility and see them doing this, like with an x-ray machine, they'll always, every time it happens, they go and they look at the chart, they look at the product, the person validates the chart recorder, writes their initials and the time on it, so they're recording the exceptions. Yeah, so they'll do hourly, so that's part of their check, like, right, their continuous monitoring. They might have like a sterile piece of metal that they set on the line, and as it goes through, it'll kick that piece of cheese off into the bin, and then they'll write that exception record on the thing that they were testing the system, so that if an inspector ever came and looked at that chart, they would know, well, that wasn't a foreign material, that was you validating your system. Okay, who's going to monitor this? This is an important part. That first word there is a trained designated employee. It doesn't need to be somebody associated with your quality assurance, though if for you guys, you are probably going to be the quality assurance people also. So it can be an operator, a cheesemaker, whoever's doing the work in there. And typically you don't want the person who monitors it to also be the person who verifies the recording of it, just because you can get in trouble. And we've seen this I've seen this before where they were doing freezer temperature checks for certain products, and you can look down the thing and the same person that's recording it is also verifying that they're recording it, and it's the same value. It's been the same value for 2 pages of reports, so you know that the person doing the validation or verifying that it was recorded wasn't checking very good. The qualifications for somebody who's going to be doing this monitoring, again, this needs to be a trained person in the techniques. You can do this through on-the-job training or some similar approach. They need to understand the importance, why they're doing this monitoring. They should understand it. They need to accurately report the activity, and they need to understand the actions to take when a deviation happens. So you need to have immediate corrective actions, and you need to timely report the deviation for other actions. And this might include like holding product, depending on the deviation, or sequestering product from the rest of your lot, those kind of things. Okay, so in our example here, if you're going through filling out your paperwork, we've identified the hazard, the process control, we've set the critical limits. We're going to use, how we're going to monitor is the milk temperature. There's a recording thermometer, typically a chart recorder associated with it. And in an HTST, it's going to be continuously monitored at the end of for both flow and temperature. And you're going to have a certified trained pasteurizer operator do it. And I think it's state to state whether you have to be pasteurizer trained, right? Do you have to do it in Idaho? I don't remember. I don't live in Idaho, so I don't know. So I see shaking heads. You have to take a certified pasteurizer training course. In Colorado, I know you do. Oregon, you do. Idaho? You do? Okay. So you need to take a course to be a certified pasteurizer operator here to run that process. Okay, we're looking at the omelet example. So this is the batch one. So the QA technician is going to check an omelet temperature at each cook station 4 times per shift using an IR thermometer. So you've set your parameter. As the omelet comes out of the oven, it needs to be greater than 158. And you've set who's going to do it. The QA technician's going to do it. They're going to use an infrared thermometer. They're going to check it 4 times every shift, so every 2 to 3 hours. And then you're going to set a corrective action. So if it doesn't meet that limit, you're going to hold back the product to the last good check. So that might be 2 hours worth of product, depending on where the check is. And you're either going to rework it. Does everybody know what rework means? So in this particular example, the rework would be send it back through the oven. Right? Sometimes rework might be can put it back into the process depending on the parameter that hasn't met. So, say it was a metal detection issue, you can send it through a more sensitive metal detector to try to find the problem. Say it's like 30 cases of cheese or something. Or discard or release, depends on how the parameter or what the corrective action is this. And then you want to determine the root cause, and you need to correct what caused that deviation. So corrective action is a procedure that must be taken if your controls are not properly implemented. A correction is an action to identify and correct a problem that occurred during the production of food with or without association with the corrective action procedure. And then it gets real legal after that. So you can get your lawyer to read that part. A corrective action must be taken when you didn't properly implement a preventive control and you've had a deviation. So you've had a deviation from your critical limit. So say it's a pH measurement, you've gone outside that pH measurement. You might, in that course, have produced unsafe product. And the corrective action needs to be appropriate to the nature of the hazard and what the preventative control was that you'd used for that hazard. So for temperature, it might be turn the oven up a little bit more. Or it could be, maybe the person wasn't monitoring it correctly, taking the temperature at the correct place or using the thermometer correctly. So.
Like an example that Eric brought up early on was about beige contamination, right? So you're making yogurt, and it hasn't dropped to the critical pH that you need, right? Because it's come out, it turns out, hey, we've got a beige contamination issue. So what do? We're going to rotate to a new culture, right? We'll need the documents. What did you do?
Okay, your corrective action procedures, this is important. They need to be written procedures, and they need to identify the steps taken. So you need to identify and correct the problem with the implementation, reduce likelihood of occurrence, evaluate affected food or for safety, and prevent that food from entering commerce if you cannot ensure the food is not adulterated or is not safe. Some examples of actions are adjustment of the process. So if it's a process, this would be something like you're seeing you're out of limit for temperature, turn it up a little bit so you're more in range for final product temperature. Or pH, maybe you need to hold it at a certain step a little longer until you hit the correct pH to move on to the next step. Some of these might need the employee to stop the line when there's a deviation occurring so you're not generating more problem product. You might need to apply an alternate process. So say you're using temperature as your control and you're having a hard time reaching that critical limit. So maybe reevaluate and use a different control like a pH limit or something like that. It could be a equipment problem. So say your HTST is having problems, you're not hitting limits, you might need to fix it. Or say you're cooking something, it could be the oven. Sometimes you need to just retrain the employees on how to either operate the process or measure the critical limit. Some examples, product examples for corrective actions might be holding the product. You might need to run different tests to evaluate it. Here's an example of that. So in a cheese process, like I was talking about, you need to hit a certain pH for your cheddaring step to make sure that you're inhibiting Staphylococcus aureus growth. Say you're just slightly above your critical limit and you've made 5,000 pounds of cheese in that area that's potential problem product. So evaluation could be, well, we don't want to have to throw this cheese away, so you take samples and send it out to test for toxin in that cheese, and it comes back clear. You can make the assessment that you can release that product based on more testing, more evaluation of that product. And then, determine what you're going to do with it. So you've tested that. You've determined it's safe enough. You can send it out. You've determined that you can feed it back into your process and rework it, and it'll come out. It'll be safe. Or in some instances, you just can't do anything with it, and you have to destroy it. And depending on the hazard, there's a lot of legalities with how you destroy that product too. So, okay, you need to have records for this. If you ask a government person, it wasn't done unless it was recorded, and that goes for everything in the food safety plan. That's why they're heavy about generating records for this, so you can prove that it happened.
Some people take pictures, you actually see pictures of people like pouring the bleach on the product.
Yeah.
Unedible, right?
Yep.
So that it's documented for FDA.
You need to record the actions that you used to identify and correct the product problem, what actions you took to reduce the likelihood that it's going to happen again. You need to have a safety evaluation for all the affected food, and then the records to determine that the food is either injurious to health and did not enter commerce. So like Sam was saying, you got to document that you destroyed it so that people can't get a hold of it and consume it. So here's an example of the Monterey Jack that's in the back. I don't know that we need to talk about that. Okay, operating limit definition. So the criteria that are more stringent than critical limits and that are used by an operator to reduce the risk of a deviation. So an operating limit would be like, so pH is a good one for cheese making. So you set an operating limit. You've got to hit this pH by this step so that the food can be considered safe. And your operating limit, say, is you got to hit 5.6 before you hit the cheddaring station. Actually, it's higher than that, like 5.8, before you hit cheddaring to be considered safe through that cheddaring process. And so that's your operating limit. And typically, you establish that operating limit. You can't establish it for quality reasons. So while you're making cheese in your make procedure, you want to hit certain pH at different steps so that your product comes out functionally how you want it to be. And sometimes you'll set it to avoid deviation from the critical limit. So you want to set it at a point where you're operating safely below or above the critical limit that you've set. And usually you want to set it so that for the process variability, so how much your process goes up and down either for temperature or pH or whatever that critical limit you've set, so that you're also still below or above that critical limit. Okay.
Right, so we talked about pasteurization, right? What is the pasteurization time and temperature in an HDSC? Remember? 15 seconds. Does anyone here make yogurt? Are you interested in making yogurt? What's the time and temperature that we treat our milk for yogurt making? Way higher than pasteurization. Yeah. 190 for a couple minutes, right? So much longer than what we need to do for our critical limit, but we're doing that right for an operational quality parameter, right? But an important thing to remember here is that that is an operating limit and it should not live in your food safety plan documentation, because that's what you're saying you're controlling yourself to, right? So my critical limit for pasteurization is 161 for 15 seconds. I'm going to operate at this operating limit that's higher for my yogurt making. If I were to put in my yogurt making operation, so 190 degrees Fahrenheit for 5 minutes, and I instead did it for 4 minutes, I would be then in violation of my food safety plan. Even though technically there's no safety implications, I now messed up my food safety plan. I have to do this corrective actions and all this kind of stuff. So just an important remembrance to keep your operation limit out of your food safety document, but remember that you have it. Monitor it through another system.
Yeah, that's a good point. I've heard horror stories of inspectors coming in and looking at your operating limit and then going back to your records and you deviate from that operating limit a lot. And if you're making cheese and you say your operating limit for pH is this, how many times do you hit those specs every single time you're going down the line making your cheese? A good amount, but not all the time, right? So, okay. Also, we were talking about pasteurization. This just brought something up. If you're making a different product than milk, then you want to pasteurize it after adding ingredients. Do you use 161 for 15 seconds? Well, he's gone. Who makes ice cream in here? Anybody? Chocolate milk? Yeah? Do you have to turn your pasture out? You have to have your end product come out at a hotter temperature after that holding tube? Yeah, and that's because you've added solids in there, so the heating capacity of that product has gone up, so you have to apply more heat to it to kill everything in there. So you have to take that into consideration also. Okay, operating limits versus critical limits. So let's look at this and say we're measuring temperatures throughout the day, and this is the graph we get as we plot those temperatures we're taking, right? And so say our critical limit is, we've defined as 165. You want to have your operating limit be in a different range than that. So you would adjust your process so that your operating limit is in an area where you would prevent deviation. So if you set your operating limit at, 162 or whatever, no, 167, I'm reading the thing wrong, and you keep going past your critical limit, you need to adjust your process and set your operating limit different so you're not creating a deviation as often. Okay, pepper jack cheese example. This shows the different corrective actions. This is for an HTST pasteurizer. There's a lot of things built into that, right? You kick off into your divert valve, opens up when the temperature's not hit, and dumps it back into the holding tank. And the other ones associated with that. And so you can build your corrective actions based on your process control. Okay? This would be where we'd meet and set. Yeah, so do you want to have any questions for process controls? Anybody? Go ahead, Eric. Sounds like more of a philosophical question. Probably because, so it's probably a pasteurization operation. It could be like how fast they're pushing milk through the facility, how the volume they're running at one time. So the longer you run that pasteurizer, the more stuff you're cooking on those heating region plates, and the less efficient it is to push heat from the heat side to the milk side. And so you got to turn your pasteurizers, got to get hotter and hotter throughout the day. And so you could generate those cooked flavors associated with it. So does that answer your question, Eric? Yeah, it could be. They might be so I can't think of a facility that's going to be operating right at the close limit of that HTST. They're always going to be some degree temperature hotter than what the requirement is, because they don't want to have to keep kicking milk back in through the system to repasteurize it again, right? Probably, yeah. Okay, anything else? Thinking about all your hazards and how you're going to control them? I see a lot of big eyes. I see a lot of tired eyes too. We'll keep moving on. It's all doable, right? When you're looking at cheese making, there's ways to build in these things, and it seems like a crazy amount of information and all the things you have to control. But like they set up here, like planning and doing your research, and Sam talked about having a process flow and how you're going to make things. That really helps you out as you try to identify potential hazards and how you're going to deal with them. And one of the biggest ways you can do it is pasteurizing your milk. Does anybody in here do raw milk or plan on doing raw milk? I know you do. You? Yeah. So, and the control limits for that one are different. And maybe we'll talk about them a little bit when we get going here.
And I'll just add, I guess, for a lot of us, we mentioned the PMO earlier, that a lot of the process controls for your facility are already defined in the PMO. It's really just going back to that document to make sure you have the right times and temperatures for pasteurization, the holding of your milk, all that kind of stuff. So you really are not reading, you don't have to go through the reading that, just go to the right resources.
Okay, everybody's favorite topic, cleaning, right? So sanitation preventive controls, we've talked about process controls. So how do you control how you make the food? And now we're going to talk about how you control these food hazards through your cleaning, sanitation.
Can you clarify? So a couple weeks ago when I was in the class, Dave Irish, the manager, said that cheese making is 90% cleaning and 10% cheese making.
Yeah, so this is, and especially if you're making a raw milk cheese, cleaning is a huge part of your control. This is probably where most of your control is coming through, is through cleaning your equipment. And Dave's right, like that's where a lot of your problems are going to occur, is dirty stuff. And in my life, my previous employment life, almost all the problems that we are associated with biological hazards all came from cleaning issues. And not just food safety ones, but also food quality ones. Almost all of those were identified through cleaning problems. So, yeah, and if you pasteurize it, then the only way something's going to get in there is downstream through your processing facility. So how you're making it, you got to keep that area clean so you're not putting those things back into the milk or your cheese as you're making it. So, and Sam kind of alluded to this, milk, microbiologically speaking, is a superfood for them. It's got everything they want, everything they could need, and they grow like gangbusters in it. So, yeah, and then you're putting it in the temperature ranges where they like to grow. So, but if you're using starter cultures for things, you're kind of getting past that with some competitive advantage with your starters and things. But yeah, cleaning. That's probably why he's got the next one in here, because it's a huge part of keeping things safe. All right. Sanitation preventive controls. Again, hazard analysis is going to identify when you want to use sanitation controls. Sanitation controls, you're going to want to monitor those, how you're doing them, and have corrections and verifications associated with those controls. So, what hazards and conditions are relevant to sanitation preventive controls? There's a couple you can use. There's environmental pathogens. This is important for ready-to-eat products. Are most of the dairy products considered ready to eat? They all are. Shake your head, yes. You don't cook that cheese, right? You just slice it off the block and eat it. Or open that yogurt and eat it. Or open that gallon of milk and drink it. So almost all dairy is in the ready-to-eat category. So in environmental pathogens, when you're working with ready-to-eat product, they become exposed to the environment prior to packaging. So we've put a critical control point in. That was pasteurization. We've killed anything coming in the milk. And the only way they get back in is through the environment in your make area or your processing area. The two biggest ones of concern are Salmonella and Listeria monocytogenes. They get transferred through cross-contamination in your facility. This can be from unsanitary objects, like tools that you use to work. It can be employees handling it, either through poor GME, like going from raw side to finished product side, process side. Okay. And then the other one can be food allergen cross-contact. Do you guys that make cheese, you ever worry about allergens? You don't put any allergens in your product, right? Yeah. Okay. Yeah, because if you use an allergen, then it becomes a different level of control in your facility, how you're going to keep that allergen out of your other products. And when we get to allergen, we'll talk about some of the ways to do that. For dairy, a lot of the times you don't have to worry about that too much. You just kind of have to worry about stuff that you're putting in your cheese. But I talked to a guy who worked for Cliff Bar, and it made my head hurt thinking about like all the allergen controls they have to do in their facility, because some bars have nuts, some bars don't, some bars have this, some bars don't. And so they have a huge portion of their food safety plan is allergy control. But you can control a lot of this through sanitation. Ice cream, yeah. So for the inclusions you're putting in, yep. So GMPs that support cross-contamination or cross-contact prevention. So these include your employee hygiene practices. So when they enter the facility, what are they doing to minimize cross contact from outside the facility to inside the facility? And even inside the facility, if you've got a raw side and a pasteurized side, you've got to have practices to eliminate that. How the employee handles the food, how you design your plant and the layout. And this is kind of important. I know the guy from Washington is gone, but it sounded like he did a lot of consultation about how to design his plant. And I've been in plants that this wasn't taken into consideration like 20, 30 years ago when they built it. And it becomes a headache later because you have to walk across a hall that is where people access the raw side to get to the processing side from the cheese make side. And so it can become a problem. How you store your packaging material, how you handle it, general cleaning and sanitizing, and then physical separation of your raw side and your ready-to-eat side, and then your food allergens, and that includes as you're using them and as you're storing them. Okay. Sanitation, preventive controls, you're looking for cross-contact or cross-contamination control. Ready-to-eat food exposed to the food, these problems, and the process on the same line as a unique allergen-containing food. So if you're making ice cream, Utah State makes ice cream, they only have one freezer. So how do they control cross-contamination with allergens, right? And I think we talk about that later.
Well, yeah, but I guess anticipate you guys are just starting off, so you're going to hear this term a lot more as you get into it. But just one of the things is in the literature, right, they talk about cross-contact versus cross-contamination. And they seem very similar, but when they use the word cross-contact, they specifically mean allergen cross-contact. So one allergen, if I was running peanut butter ice cream on the line and now I ran vanilla ice cream on the line, how do I make sure the peanut butter can get in there? Whereas cross-contamination is all around the biological pathogen of bacteria. And how do you prevent cross-contamination from one thing or the environment? Just so you know, that's how they'll spell it out. That's kind of our. You heard it today for the first time. You're going to hear it a lot. You get into
Okay, another way you control this is through hygienic zoning. And you do this in your facility to differentiate the requirements for these areas for minimizing product cross-contamination or cross-contacting, depending on if you're working with allergens or not. And we'll go through more of this in the environmental monitoring, but typically you zone them. You have non-manufacturing areas. These can be like your maintenance shop, your office areas, like where your employees have lunch, those kind of areas. Transition areas can be like changing locker rooms if you have captive things, locker rooms, or the areas going from, your non-manufacturing areas to your manufacturing areas. That's your transition area. Your basic GMP areas, like your raw and receiving and storage areas. So this could be where your incoming milk comes in, or where you're receiving ingredients and storing them. And then you have your primary pathogen controlled area, and these are this usually is a controlled access area. You don't just let anybody that wants to that can walk into that area. And this usually is separated from your raw side and your receiving sides. And this is where you're on the pasteurized side of your make, and this is where the ready-to-eat products can be exposed to the environment. And that means like sitting on your cheese table, that's exposed to the environment, right? It's an open vat. Then you have your high sensitive areas, high hygiene areas, and these have very restricted access. And typically the high sensitivity, high hygiene areas can be where you're making high sensitive products. So if you're into making dairy powders that are going to go into infant formula, that becomes a high control area. Very few people get access to that, and they have to have specialized training and specialized GMP PPE to go into that area, personal protective equipment. All right, your cleaning and sanitation procedures, you need to identify what's the purpose of this cleaning step, how often are we going to clean it, who's the person that's going to do this, what's the procedure for cleaning, and if you're developing SOPs for these, I'm guessing a lot of these small manufacturers are going to be doing a lot of hand cleaning, right? You don't have a lot of clean out of place or clean in place operations there. So typically, I've seen hand cleaning procedures where they are written down very specific on how to clean a piece of equipment. And that can save you headaches later, like make sure you clean this drain port out, open the drain port, pull this this pipe off, clean this thing out. Then you need to be very specific on how to do it. You're going to determine how you're going to monitor that cleaning, that was done correctly, what kind of corrections you're going to implement if it wasn't, and then how do you verify that it was done, and how do you record it was done correctly. So when you're documenting these procedures, practices, you need to control identified hazards. You're looking at the cleanliness of the food contact surfaces. So anything that touches product in your facility is considered a food contact surface. And how clean are those? You want to make sure to prevent allergen cross-contamination or cross-contact or bacterial cross-contamination getting onto those surfaces from unsanitary objects, personnel, from people to the food, or to food packaging materials, or to food contact surfaces. And you want to make sure that you're keeping your raw product from your processed product. And you need to document for hazards that require preventive control through this process. Okay, so here's a worksheet that you would use to determine your sanitation procedures, how you're going to use this as a preventative control for different steps. I think this is the egg one, right? Yeah, and so if you remember the Ballard's cheeses wrap, there was a picture in your presentation where you're showing you packaging cheese in there, right? And you'd have this would be your cheese packaging area. How are you going to clean that area effectively? Because that's a high risk thing to do as you're handling all that cheese, cutting all that cheese, packaging all that cheese. How are you going to clean that area in a way that's going to make it safe to package, right? And I'm sure you have procedures on how you clean all your stuff before you package or use that area before you're doing it. And this is probably more important for small processors because if you remember from his slide, the amount of room you have in your facilities, you're probably not going to have like a dedicated only process area. And even at the university, we don't have a dedicated process only area in our pilot plant. We have tables that we have to clean and use for our cut and slice and cut and package area. So how do we clean that area before we go on to that? Okay, how are you going to monitor your sanitation? So again, here's the definition, legalese: to conduct a planned sequence of observations or measurements to assess whether control measures are operating as intended. You need to monitor critical elements of the sanitation process, and you need to monitor implementation for other controls such as hygienic zoning. So how do you monitor that you're respecting the hygienic zones you've developed in your plant? And that can be, usually it's visual. You'll see somebody going where they're not supposed to or not washing their hands. Those kinds of things. So here's an example sheet of a sanitation protocol. And what you've got is your sanitation area and your goal. And then they have different times broke out in there for when you're going to do these different steps. One is pre-op, start, lunch break, post-op. And the equipment cleaning and sanitation, you're doing that pre-op. You're going to use the sanitizer. You're going to use a quaternary ammonium compound at 200 parts per million. And you're going to test and document that you've hit that parts per million in your sanitizer before you use it. And then cleaning after, so this cross contact, in this example, you're making a cheese omelet with a biscuit, and you also make a cheese omelet without a biscuit. So how do you clean to stop that? What's the allergen in that concerned? What? Wheat. Yeah, gluten. So how do you clean your equipment effectively so you're not cross-contacting that biscuit to your other products? And then you're going to check the condition and cleanliness of non-food contact surfaces, so floors, those kind of things. And then you're going to clean them using, again, this quaternary ammonium compound. But in this instance, for this area, you're going to use a higher concentration, higher ppm. And so you're going to check that parts per million and move on for your cleaning. And then it has places for comments and then the operator initials. So they've done that step, they've documented, they've done that, and they've signed off on it. Okay. So, actions to correct sanitation deficiencies, and they depend on the situation. So, has anybody in here take a sanitation course? I see somebody in the back. Yep, they have steps for this, right? So, typically you clean and then you inspect. And if you see visible soil, what do? Re-clean. So that's your corrective action, right? And you
Correction. That's correction. It's a correction because you haven't made any product yet.
Yeah, okay. Correction. So then you've corrected it. Then maybe you've got to that point where it's visually clean and you move on to sanitation, you sanitize it, and then it's sat there for some period of time and you haven't run product on it and it's exceeded the limit for how long you allow it to sit before you have to resanitize it. So the correction is to resanitize, right? So you resanitize that equipment before you use it. And then if it's not getting cleaned properly and you identify it as a procedural thing, then you retrain that person to clean correctly or perform the task correctly. Okay, sanitation verification. So these are things you do to demonstrate that their sanitation procedures are operating properly. And this can vary a lot depending on what kind of food you're making, what kind of facility, sometimes the size of the facility, and then relevance to the food safety system. So some of these examples, and this is, if you're thinking about how you're going to control some of these things, some things that are very simple to do is measuring your chemical concentration of your cleaner or sanitizer. And these can be done with little strips. So you mix up the concentration you want, you dip your strip. It's like a pH thing. You look at the thing and measure the color to the chart, and you know that you're in the concentration you need to be in. That's a simple, easy measurement verification that you're doing it correctly. You can get into, after you clean, running ATP swabs or protein swabs. You can do contact plates. These are like it's like a petri dish that you push onto the contact surface and measure microbial growth. You can do microbial swabs, so you take a swab and swab it and let the microbe grow. You can develop and implement an environmental monitoring program, and this is to monitor for environmental pathogens, and then doing a record review. So just reviewing your cleaning records, making sure that the cleaning is done correctly. And this, again, at this level of cheese making is something that's very easy to implement. Record reviews and chemical concentrations. And then like visual inspections are really easy to do for verifications of cleaning too. Does it look clean?
Just a lot of you are already running dairies. Some of you. Do you already have any chemical companies that you work with on that side? Yeah. So in some ways, sometimes small producers have a tough time getting any chemical companies to pay attention to them. Because you have that other side of your business, leveraging that relationship is helpful. They should be giving you testing kits for those chemicals, so you can verify that your sanitizer is clean and for the right concentration when you use them. And they might even help you write up SOPs for your equipment as you use those chemicals. That's, again, sometimes with my small producers, it's tough to get into the lower company, but because you have some of those synergies, sometimes leverage those to help you as you design your facility. That way, you have a little bit less work to do, and you have an outside expert help.
Yeah, I'm kind of forgetting that you got to clean all your milk stuff for the dairy side. This is an example of hygienic zoning. So you can look at it in your book. You have different areas that you say are basic GMPs. I think they're kind of hard to see on the screen here. They're so tiny, I can't see it. But the red might be, what is that one? Office areas, and I need a little help, Sam. I can't read it. Okay, so that's your raw side. So you've zoned out your raw side. Purple is your transition areas. So this is where you'd have those controls when you're going from a clean to a dirty area. Yep. A boot wash station. You farm guys, dairy guys, do you have boot washes anywhere in your facility, or boot baths? No? Okay. What? Foot baths. And they can be dry foot baths too. They can just be a bin with some like quaternary ammonium crystals in there that you step in before you go to the next area. And then you've got your green, which is your ready to eat area, and then you've got a high hygiene area. If you look at that map, there's another transition area to that high hygiene area, and it probably has more procedures you have to follow to get into that area, like boot scrubbing. Maybe you change your boots. Maybe you put on a smock or something like that. I've seen all those things. So. Okay, and then these are some written procedures for zoning protocols. So who can go into these areas, what you need to do to get into these areas, how you're going to monitor, correct, and verify that all these actions are happening. So you can read through those and get an idea of if you're going to zone or do things. Though at a small producer level, it's kind of hard to like zone everything out in an existing facility because sometimes you might need to use some of that space for packaging or something later. And so you'd probably want to build some documentation in there and how you control that through cleaning. So how do you transition your RTE area to like a packaging area, and what protocols are you going to follow to ensure that that's clean before you package? Yep. If you're building a little processing facility, it's worth spending a little time looking at how to design that so it flows correctly, so that you're not having to cross back through the pasteurizer area to get to, you know, where you're storing your cheese after you package it or something like that. So. And then environmental monitoring. I think we're just going to skip this because we're going to talk about it, right? Okay. Okay. Any questions? What time are we at? 2:30? Bang, right on the button. Hurry up and fill your plates full and come sit down. You can snack on cheese while we're chatting about allergens. All right, we're going to ask a question. How many of you guys make products that have an allergen in it? What's that allergen? Milk, right? Okay, good. So we're going to go through the preventive controls for food allergens here. When you're doing allergens, a lot of that has to do with cross-contact prevention and labeling, and also sanitation. So we've covered the allergen part and the sanitation part, right? You want to clean correctly and verify that you're cleaning so that surface is free from an allergen you might have ran on it if you're going to run a product that does not contain that allergen. Okay, Sam had already talked about the big 8. That's what they call them in the food industry. Milk, egg, peanut, tree nuts, fish, crustaceans, shellfish, wheat, and soy. And if you look at those, you can think maybe which ones maybe you're going to come in contact with through your food processing one. The one on there from my prior life in the industry that they were concerned about was actually wheat contamination, because they would make stuff that was certified gluten-free, and some of the, particularly the starter culture they used, potentially could have been grown on a wheat product that goes into your product. So when, I think you're talking about supplier verification, right? So that's one of those things you got to check if any of those ingredients come in, and sometimes they can be things that you wouldn't think would contain something that you're potentially dealing with. So we're going to go through this. Okay, preventing allergen cross-contact. A lot of that has to do with cleaning shared equipment correctly, and this would fall under your sanitation preventive controls that we talked about. The other one is properly storing or managing rework. So if you're feeding product back into the line, a lot of this has to do with record keeping, labeling, and where you're putting that stuff back in. I don't think any of you guys do rework, right? Here, where's the guy from Ballard? He's not in here right now. I know you guys probably don't do anything with it, right? Ice cream? Anybody wanting to do ice cream out there? So some of that might be you've ran a product and then something was wrong, and then you've reran that product through the freezer again.
Yeah, or sometimes like you cold our lines and ice cream with product, right? And that initial stuff that comes off the line, a lot of people tend to collect it.
Yep.
Put it back in later.
Yep, you might use a mix that shouldn't go in with another mix. Avoiding in-process or post-process allergen cross-contact. This is where a lot of your control happens if you're running allergens and non-allergenic products at the same facility. And then another category, and Sam had talked a lot about this, almost all the allergen recalls have to do with labeling issues. And those can be, you've put the wrong labels on your product that contains the allergen. It can be the way it's labeled for the allergen, those kind of things. And a lot of human error is involved. It's like every time I touch it, it does that. Okay, so ingredient allergen assessment. This is your, for a raw material bringing in. These would be like a checklist. The supplier, and you can get this information from your supplier, what would potentially contain. And sometimes you would think you wouldn't need to do this for a product that you're bringing in to use as an ingredient, but it's best to do this for all those because sometimes you're not sure, like maybe it contains a wheat that you're not sure of, so, or something, soy. Everything has soy in it. Cross-contact prevention considerations have to do with equipment cleaning and the sanitary design of the equipment. And what was his name from Washington? Daniel from Washington. He talked a lot about going and chatting with people who do that kind of stuff. And in my prior life too, it helps a lot if you're going to put a piece of equipment in or design a facility. If you do it right the first time, you save yourself 25 years of pain trying to clean a paste in that vat or cleaning an area in your facility. So it's worth doing some work with that. Manufacturing and engineering controls, your ingredient control, rework management, personnel practices. So if you have somebody that's handling ingredients that are allergenic and then going into the production facility where you're making a product that does not contain that allergen, that's a problem. And then a lot of training for all these things for your employees so that you avoid cross-contact. Okay, when we're talking about allergen cleaning, there's a lot of verifications for that. We talked about visually clean. This is like in sanitation, the minimum requirement is checking to see that it's visually clean. And if you take a sanitation course or know a lot about that, you can identify the different residues on there and what that means. Protein looks a certain way when it's on your machine. That's how a lot of equipment in the dairy industry will look. If it's not cleaned properly, it kind of looks rainbowy on the thing. If it's a fat, when you spray it with water, it'll kind of beat up on your equipment instead of making a sheet, those kind of things. There's some tests you can do. We've talked about a few of these non-specific ones. They make an ATP test, and that's testing for adenosine triphosphate, which is like the energy molecule of a cell. It's very transient, especially to sanitizers. And then for protein, if there's any protein residue that you can't see, you can run a swab that will detect whether there's protein in there or not. And that particular test is a non-specific. It just tests for any generic protein on there. It can be any protein. You can get more specific. They make tests that are on the same principle, but they test for particular allergens. So you can actually get a swab that you can swab that product for, and it'll tell you if it's got gluten in there or gliadin, which is what's in wheat that causes the allergy. They become more expensive when you move up the chain doing that. But if you're running an allergen and a non-allergen, sometimes it's worth it to verify that that equipment is clean before you run a non-allergenic code. And then you can get into some really complex tests. These can be like ELISA-based tests and other things. I don't know what else you were referring to on that one. Yeah, complex tests. This would be something where you'd have to probably send it away for testing validation.
And there are challenges, maybe a little bit in the weeds, but a lot of questions around how do you verify that an allergen is in a fermented product? Because right, our cultures produce proteases that break down proteins, and so they may not show up in a traditional allergen test, but they may still cause an allergenic reaction in a person. And so there's been a lot of difficulty on figuring out what testing then allows you to show that the product is really free from or not.
So I was saying, with fermented products, our cultures will make proteases that will break down proteins, and that can make it difficult for some of these allergen kits to detect the allergenic protein. And FDA has just put out some information where the concern was that, like, I could have wheat in my yogurt, but my cultures, right, their proteases might break down the wheat protein, and then I test my finished yogurt, and I say, hey, guess what? I did this allergen test. It says there's no wheat in my yogurt. This is fine. And I go give it to someone, and they still have the wheat allergy. They still have the reaction. The test kit cannot detect it in that matrix because of that activity. So now FDA is saying that if you have an allergen that goes into a fermented product, right, even if you test afterwards to show, right, to try to indicate that it's free of that allergen, they will not accept that. So basically, if you have an incoming ingredient that has an allergen, and then that goes through a fermentation step, there is no testing that they will accept to say that it's allergen free. So, for example, the cultures that Taylor was talking about, sometimes they're grown on something that has a barley malt in it.
It's a yeast extract.
A yeast extract, and what they're saying is that there isn't a test that you could do afterwards to verify that it is allergen free. So now everyone's going to have to go back and figure out a different type of media to grow these cultures on, so they don't have to carry through the allergen to their finished product. So
And that is how they controlled it. They would verify the media was gluten-free
free
before they did the
before they did it.
fermentation.
Yeah. So
Okay. Another way to control this is how you run your product. And if you're making ice cream, this is typically how you're going to do things. So say you're running a white base, and you make maybe 3 codes of that white base, and one contains peanuts in it. Which order are you going to run your codes, your products? You're going to run your vanilla first, then you're going to run your berry one, and then you're going to run your peanut one last. And that's how you control keeping the allergens out of the non-allergenic one, and only in the peanut one is how you run the order. And that's particularly important for like a small processor. So Utah State's ice cream, they only have one freezer. So they've got to run everything through that freezer. So they'll either schedule them on different days, or they'll schedule them at the end of runs for those ones that contain an allergen. And then how you process order. Here's an example of a monitoring record, and this is to verify and document how you ran those orders, so you can show that you ran them correctly to try to control allergen cross-contact. Allergenic ingredient control. So you need to develop a master list of all the allergenic ingredients that are potentially used in your facility, and then you can this says letters of guarantee from suppliers that it either has or does not have the allergen of interest in it. Sometimes they call these certificates of COAs, acceptance. What was the A? Analysis. And that has all the tests that they ran on it, and it certifies that it doesn't have gluten in it, for one, if you're concerned about that. When you're receiving these, there should be a master list at your receiving dock. And you need to use, when you're labeling your stuff, the common names of the allergens. And this is something that Sam brought up, where if you say whey on your ingredient list, some people might not recognize that as being a dairy product. If it says milk on there, they'll recognize, I'm allergic to milk, I can't have that. Whey, maybe they don't recognize it. You want to apply careful handling at your receiving dock. Usually you implement protocols when an allergenic product comes in that you use, how it's labeled clearly when you receive it, and then how it's stored. And typically you have, the way they like to do it is in zones and areas in your warehouse where you're going to hold this product, this ingredient. And they even like to, if you have them stacked on shelves, they don't like your allergenic ingredient being on the top shelf. So you have to think about how you're going to store them to avoid cross-contact. And then you can identify allergens with icons. They actually have a big set of allergenic icons that are, I think they developed these how many years ago and accepted them? Yeah. But you can print those out and slap them on your stuff as you're storing them. So you want to review the labels of incoming raw materials. You want an allergen check as a prerequisite program for your suppliers. And you want to color, these are all things you can do to make sure you're not cross-contacting. Color coding your palettes or your labeling is really useful. I've seen that happen too, where they'll use like a yellow palette only for this particular products, like say it's a palette of nuts or something. And a lot of it has to do with separating them, how you store them. Some of these you guys probably never going to run into. Though I have seen some, I was just thinking about it while we were at the break, some weird cheeses that have like walnuts in it and stuff, where you potentially could be using those.
Yeah, another one that had been in vogue is pink peppercorn. Some people have been using pink peppercorn, and it turns out it's not a peppercorn at all, right? It's actually related to the cashew, and so pink peppercorn is actually a tree nut allergen and needs to be declared. A lot of people didn't realize that when they were using it in their cheeses, and then had an issue with a recall because it was an undeclared allergen. So sometimes think about the types of the types of inclusions you're using for your cheeses.
Okay, during processing, how you control this, you want to segregate the allergenic material during processing, and this can include, typically you'd have a procedure where you weighed out the amount of ingredient you were going to use in a different area, so that if it's say it's a powder and you dump that powder into the thing and now your powder's blowing around in your processing facility, you want to avoid doing that. You want to use covered totes or some way to contain it during transfer from your storage area to your processing area. You want to control the ventilation where you're measuring out those powders because it can kind of spread all over. Typically, if you're running allergenic stuff, you're going to have dedicated tools and equipment for that identified allergen. So say you're using peanuts, adding peanuts to something, you'd have a red peanut scoop that was your peanut scoop where you scoop those with into your measuring thing. And then you want to use proper containers that previously held the food allergens. So I've seen this too on finished product or product that comes off the line for potential rework. They'll have different labeled tubs or totes that product goes into for storage and handling. And usually, if you're making a lot of different allergenic stuff, they'll have dedicated lines and processing equipment for each allergenic code and non-allergenic code. But for a small processor, it's something you can't do, so you have to find a different preventive control to deal with the allergens that you're using. Does anybody plan on making like some weird yogurt with pink peppercorns in it or something? If you ever get to where you want to do that, it's good. You have some good information. Labeling considerations. This is where most of the problems occur. You want to have accurate printing of allergen ingredients on the label. There's requirements for how big that lettering is for certain things. And you want to make sure, and this is where a lot of this happens, is you put the right label on the right product if you're making an allergenic product. This is where a lot of the recalls happen, where the person loaded the wrong label into the machine and they ran a pallet of this stuff before they realized that it had the wrong label, or sometimes it'll actually make it into market with the wrong label on it, which is a huge problem.
Here, I can throw in a horror story because I have plenty. I have tons of allergen horror stories. So we were making fudgesicles and popsicles on the same line, right? They use the same molds, just change, right? One's got dairy, one is fruit. Well, they were loading the boxes on the line, right, to get filled, and it turned out they were putting the fudgesicles into the popsicles box, right? And it went out the door, and now we had an undeclared dairy allergen in our popsicle boxes. And so we had a wonderful, large recall, which was a huge issue. And then what we ended up doing was the engineers came back and they redesigned the boxes for popsicle and fudgesicle. So they were physically different sizes. So the operator could not physically place the popsicle boxes on the line when it was set up to run fudgesicles, and vice versa. So that was a fun one. Yeah.
All right. And along with that, product labeling and packaging. Consumers, if you're allergic to a product, this is like the only way you can tell. And does anybody know anybody that has food allergies in here? You don't have to have one, but do you know anybody? I know a few people in my family do. What do they do every time they're going to eat something or buying some at the store? They pick that thing up and they read it and examine it thoroughly because they want to make sure it doesn't contain that allergen on there. And so we were kind of having a discussion during the break too about, labeling your product as a dairy allergen, and it seems kind of dumb, like, yeah, it's cheese, but what's the requirement, Sam?
Yeah, well, it has to say milk, right, in the ingredient label. If not, it has to have a contain statement at the end. And some people do it in both. You'll see the examples from FSPCA like to have you have it in both. So, but it needs to have the specific name of the allergen, even though you say, oh, it's cheese, it contains cheese. No, it needs to say milk.
Yep. Okay. Companies, product recalls, regulatory inquiry, or potential liability. That's all problems with having the wrong packaging. And this it's not as serious as having a food microbial outbreak associated with your product and having to recall it, but it's still kind of a serious issue for you. So you'd implement preventive controls for your food labels. Sam talked about they identified a hazard in their labeling for their popsicles, and they went back and reassessed, and their preventive controls was having different size boxes. So it made it physically impossible for them to do that again. But some of your preventive controls for this could be like two-person verification before you run the label, or I'm trying to think of some other ones they might do.
They'll have some examples.
Oh, okay.
Yeah.
Oh, here we go. So allergen label verification, these would be different products, the allergen statement, and then the label number associated with it.
So this would be when you get them into your facility, right? You might review them right when they come in to make sure that the labels that they've sent you have everything on there. So, for example, we were talking about another producer. They had bought their labels, and they were worried about it. They didn't have a contained statement, but they did have milk in the ingredient label. But this way, you check it out beforehand to make sure you don't have a problem.
Okay, and I'll throw this in because I did an allergen training program, and they had a consumer advocate there speaking about it to the people. And a lot of companies that process things like to say like may contain or processed in a facility that handles whatever allergen of control is, and that's kind of like, in their point of view, like their get out of jail free allergen declaration card, right? But it's not a good way to do this, and there's a couple reasons why, but one of them in this consumer advocate was like, if you're allergic to peanuts, and everything you go says may contain peanuts or processed in a facility that also handles peanuts, then what are you going to eat? So as a producer, like you can be responsible to those people and give them an option of something to eat if you do everything correctly, and then you don't have to put may contain statements in there. And also, putting that on your label does not get you out of jail free for not having proper GMPs or preventive controls for cross contact too. Okay. All right, preventive control program. This is would be an example of a sheet as you're making your preventive controls for the allergens you handle, and this is kind of similar to all the other ones. You've got your hazard and all the criteria you're going to run. I think the next example is the cheese. No, French vanilla ice cream. So your hazard is a chemical. It's got milk, egg allergen in there. So your criterion is contains egg milk statement below the ingredient statement. Monitoring, you're going to check the incoming labels. You're going to have an evaluation checklist for all the newly received labels. And I've heard of this in the industry too, where they didn't conduct a label check when they ordered their new labels, and it just didn't have that statement on there, and they thought it did, and they ran that product through. Who's going to do it? You're going to have somebody you have identified. In this instance, it's somebody from quality assurance. And if you see the label and it doesn't have that statement on it, you're going to reject it before you receive it and get the company to send some more. And then you're going to have a verification that you're going to record. And the records you're going to keep was this label evaluation checklist that you've developed for your receiving people. Is this different? Huh? Oh, this is when you're running your product. Okay. So this is again your critical control. What you're going to do is the contains egg milk statement below ingredient statement label. And how you're going to monitor is placing the labels on the product package correctly on the correct product. You're going to check labels versus the product. So some schedule, how you're going to schedule it, how often. This one says at start of shift and change of lot numbers. And then who's going to do it is going to be your packaging operator. So the person who's running the packaging, or in your case, it might be the person putting the cheese into that package before it goes in the vacuum packer. Corrective action would, if you notice that the labeling is wrong, you'd put that lot on hold and hold it and determine the cause of why that wrong label is placed on there. And this would be one of those instances where you could still release the product with an intervention like relabeling or something. So, okay, we already talked about sanitation, cross-contamination. Does anybody have any allergen questions? Do they have to be approved? Do they have to be approved? Is that what you're asking? Yeah, that's a question for Sam. I don't know.
Yeah, no, in FDA's world, there is no label pre-approval, so you don't have to worry about that. You'll make your labels, and then you'll find out if you have a recall afterwards. But yeah, there is no pre-label review. Yeah.
But they do have criteria for the wording and how.
Yeah,
big.
there are labeling requirements around, and I think even the lawyers mentioned around font size, nutritional label, but all those pieces fall under the Labeling Act, not under FSMA, so you still need to be compliant with those. But there is, again, there's no agency that is constantly reviewing these labels to verify whether or not they are correct. You're on your own for that. Yeah.
Until you get in trouble. Then.
But you can make a wine that's under 7% alcohol, and then you don't have to worry about TTB either. So. Yeah.
All right. Any other questions? Okay.
So in that same vein, I come from feed manufacturing world, and if we're selling a feed to multiple, that's not a commercial, that's not a custom feed, it has to be registered with the state, whatever state you're selling it in, and each state is different, has required their own registration. That's not the case either with food products.
Yeah, no, there's no, at least not in New York, we don't have to register your food labels with anybody else. No.
So your tap feed, your milk replacer are more highly regulated on labels than.
It might be, yeah. It's not that it's not regulated. There are regulations. It's just that there's nobody that is going to. Just think about the volume of food products that are out here in the U.S. I mean, they don't have a system that's fast enough to review those. So. Yeah.
The reason the states want to is because we have to pay for each one too.
Oh well, there you go.
Oh yeah, the state has a different way of getting your money from selling your cheese, right? Okay. Any other questions? These are good questions. Just think about it too. How many SKUs does a grocery store hold? Yeah, maybe 100,000. Who's going to review? Who's in charge of reviewing all those in the state? That's just one grocery store worth of product. So, all right, we're going to move on, and I'm excited about this because I'm actually a microbiologist and not a regulatory person. So, we'll get back into some microbiology here. So we're going to talk about environmental monitoring. When we're talking about organisms, microorganisms in dairy facilities, food facilities, there's two types that pop up in the facility. You've got your transient microorganisms and your resident microorganisms. And your transient are ones that just come into your facility and are gone. So these can come in via raw materials, like your raw milk. People can walk them in. Sam talked a lot about hazards of bringing in microorganisms. The people are a big source. So say, for you dairymen, what are you doing before you go make cheese? You're out there with your cows, right? So you might be running the tractor in there with them in the feed, in your milking parlor and stuff, and you're walking in stuff you don't want to walk into your facility. But that's an easy way to get some transient microorganisms showing up in your facility. You're walking them in on you. They can come in on packaging materials. Typically, these ones are killed through normal cleaning and sanitizing. So if you're following your normal sanitation procedures, these organisms are dying. They're not going to stay around long. And typically, for most of these, they do not become established in your processing production environment. They'll die or based on they can't survive the environment, or they don't have the correct food or conditions to continue to grow in your environment. The other ones are resident microorganisms. And transient microorganisms, some of them can become resident microorganisms. They come into your facility and they become established in the environment, and they can last for a long time. And I've got stories of some of these from a lot of places where they've matched organisms 10 years down the road, and it was the same niche organism coming out of a wall into their cereal product 10 years later. So once they become established, they can hang around for a long time. And normal cleaning or sanitation may not control the numbers, or it may control the numbers, but you're not going to get rid of it. So they can become problematic because they become resident, and then a lot of your mitigation is you're just knocking them down to a level where they're not causing a problem, but you're not necessarily getting rid of them. And I did a lot of this in my prior work life too, and mitigation might be you tear your floor out because you've got a spot where listeria is harboring and you can't get rid of it. You know, you'll clean and do all this stuff and it'll test negative in that area for months, and then it'll show back up again. And, you know, maybe it's some floating tiles, maybe it's like the foot of an equipment going into your tile floor, and it's established in there, and they're super hard to get rid of. And typically the microorganisms like these can survive lower temperature environments. They make like biofilm, like protective coatings on their little niche area that protect them from chemicals, like your sanitizers. And so they can be very problematic. So you want to try to stop transient microorganisms from becoming resident microorganisms. And a lot of that has to do with stopping transient microorganisms from getting into your facility. So facility hygienic zoning and GMPs. So you want to document assessment of the facility. You want to consider what your infrastructure is, the personnel that are going to be working in there, and what materials and how they come in and out of your facility, and how you want to control that. Crossover areas are a big concern, and we've talked about some of those. If you're going to design your facility, you don't want to have to walk across the entry, you know, the hallway in your raw milk area to get, you know, from one side of your processing to your other side of your processing. Room air is important. Having positive pressure in some area, so you're pushing things when you open the door, it doesn't blow in. If you're using compressed air, you want to handle that if you're using it for direct product contact. Just FYI, compressed air is not a great way to deal with anything in a facility. Neither is pressurized water. So high pressure water is bad, and high pressure air. So you can think about cleaning out an area, and maybe you think, I'll just go get my air hose and blow this out. Well, now you've blown it into the air and it's gone all throughout your facility. And you get that same way with high pressure water too. You don't want to be using that. Okay, when you assess the need for zoning and environmental monitoring, you want to identify, does this product formulation have something in it that's going to kill a potential pathogen from the environment if it gets in it? And some of these would be like a high acid food, so something with a pH lower than 4.2, about 4.2. So there are some products where you don't have to worry too much about this. A lot of them have to do with like canned tomatoes or one if the acidity is low enough, or the pH is low enough, the acidity is high enough. Is the product or ingredient associated with pathogenic contamination as it comes in? This has to do with your supplier verification. Is something you're going to be putting in your product a potential hazard of being contaminated? Does your product receive a validated process control designed to kill environmental pathogens? In dairy, is there one of those? Is there a process control? We've talked about it. Which one? I hear a lot of whispering again. It's getting late in the day. What? It's right up front in the process. Pasteurization, good. So that's a process control that is designed to kill pathogens, right? In your milk. So there is a process control in there, but dairies, especially cheese, is problematic after that because there's no other one. Is the product exposed to the environment after the kill step before packaging? Can you think of in cheese? Does that happen? The whole time after pasteurization, right? It's exposed, especially depending on how you're going to make it. A lot of small producers have open vats too. So if you saw beehive cheeses set up, they don't have any enclosed system in their building for the cheese making in their vats. They run it all on open vats, open tables. Are ready-to-eat ingredients used to produce ready-to-eat product? So are you using something that certifies ready-to-eat to make your ready-to-eat product? And then does a refrigerated ready-to-eat product support the growth of Listeria monocytogenes? So a lot of times when we're talking about, particularly in cheese and dairy, is Listeria monocytogenes. And there's conditions. Listeria is a unique organism in that it can grow at low temperatures. So even if you put it in the fridge, if it has the right conditions, it can grow up to a level that's going to make you sick or make a person sick. And there can be conditions in your food product that will inhibit that Listeria from growing. And it can be like a combination of things like salt level and pH that might inhibit it so it doesn't grow. And as you're going through this list, you're checking things off or not checking things off. You got to determine whether you got to test your environment to see if these organisms are there to keep them out of your product. So we've talked about hygienic zoning a couple times. I don't know. Let's skip through this one. We've talked about this map where you've got your different areas, your RTE areas, your high hygiene areas, your transition areas from your basic GMP into your more controlled area, your RTE area. And this might look different in your facility too. Like that hallway might be technically a red hallway, depending on where it's leading from, going into your production facility. We've gone through these ones too, raw product areas, ready-to-eat areas, high hygiene areas. You can read through these as some of the controls you need to use in those different areas. I don't know that I need to go through those anymore. Okay, so when we're talking environmental monitoring, the purpose of doing this is to verify the effectiveness of your sanitation problems or processes. So this portion of environmental monitoring can be very simple, like protein swabs on your equipment to verify cleaning. You can also use these to verify hygienic zoning is working, so protecting cross-contamination or recontamination, or to monitor harborage points or prevent harborage points from occurring for microorganisms. Another way is to create a baseline of normal for your environmental conditions, and a lot of places will do this, and they keep very good records to see what baseline is for different organisms or different groups of organisms. That way, when something has changed or something, you can identify when you're seeing something unusual happening, like a spike in something, and then try to identify what conditions or what happened to cause that to spike. And these are all really very specific to the facility. I worked for a company that had 9 giant processing facilities, and each facility had their own food safety plan, and each food safety plan had a very tailored environmental monitoring program that went along with it. You can include pathogens. I think at the small producer level, I don't think there's a lot of people that are doing environmental monitoring for pathogens. You can correct me if you know some.
There are some small producers that are beginning to test for Listeria, at least Listeria species, so which might be really considered an indicator for Listeria monocytogenes. But they're usually doing, and we'll talk a little bit about the different zones, usually staying away from the food contact surfaces, at least to begin, and doing, a few swabs a month or a few swabs a quarter, right?
Yeah, you don't need to start crazy. You can start small, looking for things. I think you kind of talked about that in one of your slides. Start small and get going. Indicator organisms, we could go really deep into what this means microbiologically, but usually they indicate some situation. A lot of it you hear a lot of this used in water monitoring. They're looking for indicator organisms that indicate fecal contamination. In environmental monitoring, a process facility, typically they indicate that the stuff hasn't been cleaned correctly or sanitized correctly. Usually you don't want to use indicator organisms as an indication of pathogen-free stuff. It's typically they don't like you doing that because it doesn't technically fall in the same group. And then you'll find people doing environmental monitoring, and they'll tell you, I haven't had a positive swab for 6 months. And you think, you're not looking hard enough then, because it's in there. And so the FDA they want you to find this stuff. If you're not finding it, they consider you're not looking correctly for it or doing enough testing or working for it. And also those negative results aren't really useful for you. You want to try to find the organism. And in a big facility, their QA guys would have incentives for their QA technicians. Sam's nodding his head, he's probably heard of this too, where you get gift cards if you're the one that month that finds the most organisms in the facility, because they want you digging around, because if it's better to find it in the corner in a little hole than it is to find it at the base of your equipment. Then you can control it in that area instead of letting it creep in towards where your food contact surfaces are.
Yeah, and I'll just add there, like, and maybe it gets a little bit on the slide, is that for diligently finding, when we're talking about Listeria, which is really the main one that we're focused in the cheese world, right? Maybe not the powders, but at least in the cheese world and ice cream, is Listeria likes to live in cold places that are wet. So and are dirty, right? They have nutrients for it. So when you're going through your facility, you want to be looking for those spots, right? So if you've built your facility, start looking for areas that collect water, right? That are hard to clean, hard to reach, rather than just swabbing like the open floor. Like over here, it doesn't really matter, right? But, underneath the chair or the underside of the table might be harborage zones. So think about that. That's where Listeria likes to be. And if you can, when you're designing your facilities, if you can make it as easy to keep dry or dry quickly, it makes a huge difference. Because it's standing water, nutrients that really provide the area for Listeria to grow. And, we talk about not finding positives, so I'm going to knock on wood here. So our dairy facility at Cornell, the guy who runs the pilot plant, we have been looking for Listeria within that facility for years, and we have not gotten positives, and we give incentives to the grad students to go in. New grad student comes in, go in and swab. And we haven't found anything, and the thing is that facility is really, really dry. Like, we only run a couple times a week, and it is super dry. So there aren't a lot of great harborage spots for Listeria. But I've gone to wet ones, and you can find them right all over the place. So if you're designing your facility, make sure that there's an easy way to get that water off the floor quickly and that the room can dry very quickly, because that'll save you a lot of headaches down the road.
Yep, like proper sloping to drains and those kind of things. Coming from both sides, again, our dairy plant, I run my class and we swab the dairy plant very thoroughly looking for this, and we haven't found it since I've started. And they only run cheese maybe once a week. They run their ice cream a lot, but the floor's dry. And coming from a big giant facility that made cheese that ran 24 hours a day, they only ran cheese 20 hours, and those 4 hours were sanitation and cleaning. There was places in that facility where the floor never dried, ever, the whole year. And you can kind of understand why they have a problem with that. There's always water. There's always the microorganism food getting into those harborage points, and it becomes a lot harder to clean. So you kind of are at an advantage as a small producer where you can get the right conditions where you don't have these issues. All right. When you're developing your program, bias target of the specific facility, equipment, history, products, ingredients, and final products. So you want to look, you're trying to find it. You want to identify areas where you can find the organism of interest. For low moisture foods, you're concerned with salmonella. I don't think any of you guys are doing any powder, probably plan on doing any powders or anything. But big dairy processing facilities will also process their own whey into powders. So it's a concern for them looking for it. Salmonella can survive dry conditions under the right conditions. For ready-to-eat refrigerated foods, which is what all dairy falls under, your biggest concern is Listeria monocytogenes or other Listeria species. Monocytogenes is the pathogenic one that causes the most problems, though there are some other species that can be human pathogens. But typically when you're testing, you can either target Listeria monocytogenes, or a lot of companies will just look for Listeria species. And their thought on that, and it's a good thought, is if it's a Listeria species, it doesn't matter. We're going to treat it like it's monocytogenes and try to push it back to where it came from or get rid of it.
That's what I was going to know, is that with the species, it may not be a pathogen, but since they're related, they can all grow in the same environment. If you find Listeria species in a harbor zone, then it's a good idea to address that, because it means that if Listeria monocytogenes made its way in there, it'd be happy to. So,
Eat something. Okay. How often you sample depends on the zoning. So if you're talking about your non-manufacturing area, your basic GMP area, transitions to primary pathogen control area, which would be your ready-to-eat area, you're going to sample more in that area and less in your non-manufacturing areas. There's places where you could swab the warehouse and get positives all the time, right? Doesn't matter if it's out there. It matters if it gets into your ready-to-eat product area. So you still want to monitor, but it doesn't give you any information if you're just swabbing your dock or, your receiving area or wherever. In that sense, the FDA has these different designated zones within your facility that go from least problematic to most problematic. And zone 4 would be any non-food contact service outside your processing area. Zone 3 is a more remote non-food contact surface in the processing area. So you can think of like the floor or the corner of your thing. And it's in there, but not anywhere near. Zone 2 is non-food contact surface that's close proximity to food contact surfaces. And that can be, say, the cheese vat. That's the side of your cheese vat on the outside. That's a zone 2. And then a zone 1 is anything that touches food. So if it touches your food product, it's a zone 1.
keep going through it. We're going to be cutting close to time, but this EM stuff, you're going to be hearing a lot about it through your time as a cheesemaker, and it's probably the most critical part of this afternoon too, right? Besides the hazard analysis. Yeah.
So, your brine? That's a tricky one.
I don't have I would consider, how often do you change your salt brine?
Probably never, right?
Right. Only once a year. And
Yeah.
have you been, do you test throughout the year, at least like salt concentrations and things like that? It's totally saturated. Okay. And any pH adjustments that you do to the brine? No. Yeah.
You're probably not adding any
Did you-
hypochlorate too.
Go through that, right? You know, I would at least consider start doing it at least quarterly, right? Just to get an idea, dip your toe in. But again, its ability to grow there will be, if it's saturated with salt, it's not as big of an issue. There are some lower salt brines that can definitely become a challenge with Listeria.
Yeah, when
So-
you hit like 15 to 20%, like Listeria could probably still survive in there. It will never grow. It will never grow in there. So it might show up sometimes and slowly.
But this is a challenge that everyone has been
Yeah.
sidestepping around on brines, because
Yeah.
yes, yeah.
Yeah. Yeah. I've worked in a facility that had, 30,000 gallons of brine they had to deal with, and they change it maybe 6 months, but they do other things to it, like they'll dose it with chlorine. They run it through a UF system to get solids and stuff out of it. So that's a good question. That's a good recommendation.
Yeah, or if you can pasteurize it more frequently, things like that, right, are all things to help. Because you got to think that if you have a positive, that implicates a whole year's production of product. So anything you can do to break that up. Yeah, I know it's not reasonable to pasteurize it every time, but think about upping the frequency.
Depending on the volume too, like it's a lot of cost dumping your salt brine every month or something. Yours might be 100 gallons, but think about 10,000 gallons. Like that's a significant cost. Okay, people and tools. So you got to train the people in the right technique. Usually you have a training protocol on how to do this. Though once you've trained that person, sometimes you just like to let them go out and tell them be aggressive with it, find it, and they can do it. The tools will depend on what you're doing and your facility. They make all types of swabs and sponges to use. They make sterile ones already in buffer that you can swab with and pop in the buffer thing to send off for testing. Contact plates, you see those left often. Floor sweeps, so if you're doing a dry product or something, you might sweep your floor and collect that and send it off for testing. Dust accumulation, so say you have a dust filter. I've seen people cut filters out of all sorts of things and send them off for testing. And then if you're concerned about stuff blowing around in your facility, you can do air sampling. They have specific air samplers that'll suck air through a filter or directly onto a petri dish. And then you can take all sorts of courses for different product categories for what you're going to do your environmental monitoring on. Where and when to sample. You want to clearly define where and when the samples are being taken. Sometimes this is to evaluate your cleaning. So you might state after cleaning, before sanitation. And that's key because if you get your sanitizer in that swab, it might kill the organism before it gets tested. Sometimes you might want to swab prior to start of operations. After cleaning and sanitation, you get to determine the step, but you want to design it in a way that's going to be most useful for you, for the information you're going to gain from it. If you're doing during production operations, maybe you define it no less than 3 hours after the start of production, end of run, end of operation shift, or at shutdown before you start cleaning. And then during special events, we would call these at Leprino like, now I'm forgetting the word right off the bat, but an adverse event. So if you're having a construction period, you might want to sample more if you're working on a facility next year's. If you got a new process area, you've just installed some new equipment, or a major maintenance activity, or say like an environmental issue, like you've had a roof leak, which happens in big processing facilities all the time. You've got water coming down. Maybe you want to sample more around that area in the next week or two to make sure nothing's gotten in there. Target and action limits. Establish a baseline to monitor trends. So sometimes at the beginning you'll sample more often to develop a baseline. You want to attempt to capture kind of like a picture of what's normal in your facility. And sometimes you need several sets of data to cover seasonality. For spore formers, this kind of happens in this fall and stuff. You'll get more spore organisms showing up. And then detection of a pathogen in zone 1 requires immediate action, as product may be contaminated. So if you're really into this and you're doing pathogen testing and you're doing zone 1s, if one of those ever comes back, it triggers a lot of stuff to happen. It's like finding it in product. So a positive on a zone 1 is equivalent to positive in a product.
And so FDA really wants people to start swabbing zone 1s, but definitely take your time to get there. First, understand what's going on with your zone 3s and the zones that are right near your food contact surfaces. And once you feel like you have that pretty well established, then slowly start working in zone 1s to kind of build that confidence. But definitely don't start there. And with your first facilities, since you're building from scratch, a lot of you have an opportunity to kind of get a baseline very early on before you start producing, and then track it over time. So if you have the time and resources to do that, I'd highly recommend it.
All right, if you get a positive in your facility, you want to review infrastructure and equipment in the area. Go look at it physically, see if there's an issue you can identify easily. You want to do some targeted extra cleaning in those areas. And some of that might include, for listeria, putting a lot of things I'll see is they'll identify a potential area and they'll just dump a scoop of quark crystals into that area. You want to review your records, make sure the cleaning was done correctly, your environmental baseline data, and then if there's been any like maintenance or mechanical downtime in that area. Test samples from composites individually. This applies to if you take 10 swabs and you put them all in one sample. A lot of people will do this to save money on testing because it costs money to test, right? So you'll swab 10 places and put all 10 swabs into one, and they'll test it. And if they all come back, it comes back negative, all 10 were negative, but if it comes back positive, then you got to go re-swab those 10 areas to identify which area was the one that had the problem. And then you want to institute a corrective action. That depends on which zone you found it in and kind of what the trends are, either a single isolate or if this area has been positive for a month or so, then your corrective action is going to be different, right? So here's an example of environmental monitoring for sanitation prevention control. We'll let you guys read that. Again, adverse event, we kind of talked about this, a situation that's associated with an increased risk of an environmental contamination. This can be the roof leaking. This can be a bird getting into your facility. This is I've seen this happen before. Like a bird's got in there and has been in there for a day or two. That's problematic for you. Something else has happened where you've had this adverse effect that could potentially cause you a problem. A floor drain back up, that happens frequently in large facilities that is pushing a lot of water through the facility, like their drain will plug, and you'll see gross water just coming up out of the floor. That's an adverse thing, especially because drains are potentially notorious harborage points for pathogenic organisms. Your environmental monitoring records, you want to track the trend environmental data, collect and record the data so you can provide actionable information. So a lot of people use spreadsheets, and in a big facility where they take maybe 300 samples a day across the line, they'll have these giant spreadsheets that go on for 1 million lines because they're tracking trends. Your goal is to so if you get a positive or you show these things, you want to demonstrate a controlled environment. So it's clean, you're keeping the problem at bay. And then, a lot of people fear, like, if the FDA, I get a positive, I'm going to get hammered hard from the FDA, and that's not necessarily true. If they come in and do an audit and they see that you've had a positive, they do not care if you have demonstrated that you've done some sort of mitigation, that you've taken action based on that positive swab. So it's not a negative thing if you use that knowledge to try to fix the problem and you've recorded again what you've done to mitigate the problem. So tracking results example, I don't know if we want to go through these.
Well, I guess we're tight on time, but yeah, it's
Okay.
it just shows how you can use the data to help you go through.
Yeah, and a lot of
out.
places will have like a floor map of their facility, and they'll track positives as they get them in different areas as it goes through. So like this example, week 1 you show it here, next time it show it here, next time you show it here, next time it shows up over here, and right there you've got a structural column and you've got a gap around the tile around that column that could be a harborage point, and so you're trying to fight it back into the area. And then you see that your traffic flow goes this way, and so you're potentially tracking that into other places. So a lot of times when you try to fix that, one way is to modify employee traffic. So you make it so they can't walk past that post when they're walking around the facility. When you're interpreting your environmental results, get all your data, and then try to decide what's happening, reconstruct what's happening, where they were collected. And then you want to try to interpret your results and then do additional testing to confirm what you think is happening, document what you think the root cause is, and then take action to correct. And I would say document that action, probably put that on there too, document it. I think you probably cover that in the...
Yeah, and I'll just stress on this slide, please, if you get a positive, do something about it and document it. I mean, unfortunately, we in New York, we had a case of an artisan cheesemaker who had also gone through quite a number of classes, had gotten a number of positives within his facility, and did not respond to those positives. And we ended up having 2 people in New York die. So, you've got to, if you're going to take the time and the money to do this investment, invest and protect your business and respond to it. It makes a big difference. So.
And then validate your action, typically through more sampling. So. All right, this is kind of a flow chart for environmental sampling, like what your options are depending on the outcome.
Right. There's a guidance document if you guys want to later on from FDA, which is still in guidance, which doesn't mean that this is what they're requiring you to do. And I don't know that they will ever transition this to a non-guidance document to require people to do it. But this is kind of what their thinking was about 2 years ago on how they would want people to respond to positives in the environment or positive onto zone 1. So it's a little bit early on for some people, but in the docket, there is a reference to that website and you can check it out. Yeah.
Yep. All right, you want to review your program at least yearly and modify it when you need to based on corrective actions, or you've got a change in ingredients or how you're processing things, or if something's changed in your facility like equipment or an adverse event has happened. And if you're consistently finding no positives, you probably want to assess how you're doing it, because it's not helping you any to just keep doing it that way. So this is the draft guidance that you was talking about, control of listeria and ready-to-eat foods. It took them like a million years to develop this. They kept saying, we'll have it out next year, we'll have it out next year. It finally came out, and I'm in agreement. I don't think they'll ever make this like a hard rule for anything. So, all right.
Then, and I'll just note again on the adverse events, just an example for people to think about. I had a small dairy producer that had a storm went through, and it broke a window that was in their make room. And so they went back through, and they decided to go back and do some extra swabbing. And they found, before they started producing again, they found listeria in their vat equipment and that area around there that had come in. And so they went back and they re-cleaned everything, did an intensive cleaning, went back and re-swabbed, and were able to show the state regulatory officials that they had addressed that problem before they started up, and so that they felt comfortable, right? So that, again, just the importance of how you can leverage these environmental monitoring programs to actually help you and help the consumer. So they can be very helpful and very effective. It's just making sure you step into it with a very thoughtful process. And as you get to that step in your facilities, that's why we're here later, for you to come out and reach us. And there's also a lot of courses that are dedicated solely, like a 2-day course on environmental monitoring programs that I highly recommend, because this is just scratching the surface. So, yeah, we're good. And then I know we're getting kind of a little tight on time, but all right, I'm going to jump to the last control for this program. Unless are there questions around EMP programs that people want to ask a little bit more? I know it's a lot of, no, you're just shuffling. Yeah.
So, does the EMP programs, do they apply, how much do they apply to people that maybe are not required to apply to physical?
Right. So if you are a qualified facility, right, you are saying that you're controlling your hazard. So what I would recommend in that situation is still consider doing a few swabs a quarter around and rotating them through different spots to get into, because you're eventually going to grow, and it'll be something you should be doing. If you start with indicators, that might be an easy first step, but I think you should consider stepping into it from the beginning. So, yeah.
But the full compliance that we just are talking about,
Right. Right. That's right. Yeah. Right. You could still be verifying your sanitation programs through other methods, but FDA will really want to see you grow into that. So, yeah. All right. Our last set of controls are going to be supply chain preventative controls, and for some of you, right, if you're making a pretty straightforward cheese, this may not be as big of a component. And again, if you are a qualified facility, you are exempt in the beginning from having a supply chain program. But there are some things you should know about it, and you should at least be doing some of the due diligence, as some of the things in here might be difficult for a small producer to accomplish. So we're going to talk a little bit about our position in the supply chain, what a supply chain program might look like, and a little bit about the records that we might keep. So again, like all our other preventive controls, all right, if we've identified a hazard associated with an ingredient that we're bringing in, we might then have a supply chain control, okay? So there might be some ingredients that don't have a hazard, which then don't require preventive control, right? So if we're using vinegar, I think in Dan's, if you notice quickly in Dan, when he showed up his stuff, he had vinegar as an ingredient. Vinegar is not associated with a hazard, so it doesn't need a supply chain control. Now, you may have a supplier program, right, for quality and all those other things, but then it would be separate from your food safety plan. Things like salt, right, will not require right, a preventive or supply chain control because there isn't really a hazard associated with it. It's key around one that has been identified in an incoming ingredient, and specifically, we're here, right? If it's an ingredient that you're going to treat within your facility to kill that pathogen, then again, you do not need a supply chain control program. It's only an ingredient that has a potential hazard that you cannot control for in your facility. So, for example, right, if you're adding herbs, right, to the surface of your cheese, those herbs potentially could have something like E. coli or salmonella on them. You're not doing anything to those herbs, so now you're relying on your supplier to control the hazard of potentially having salmonella or E. coli in it. So now that's an instance where you're going to be required to have a supply chain control program. And so, right, again, this question is who controls the hazard? And so it could be the supplier, right, the person who raises, right, the animals, the grower of the vegetables. Is it the processor, you? And some of you, right, many of you have been, right, the supplier. You supply milk, right, to a lot of companies. Typically, right, that receiving facility, that the cheesemaker you're selling your milk to, they're controlling the hazards, right? Because there might potentially be pathogens in that incoming milk. But they've got pasteurization, so they're controlling it, right, for you. But if they're not, right, and some of you are going to be becoming both. So that's again, a way to think about it. So who controls it? Or if it's a product that's supposed to be cooked, right, you're selling it to a restaurant, or it's a non-ready to eat, then maybe it is being controlled by the customer, or maybe, you know, you're selling it to another processing facility and they might be the ones who control it. So again, a supply chain control program is not required when you haven't identified a hazard in your hazard analysis, or when you, the receiving facility, control that hazard, or in some cases, if your customer that you're selling your processed cheese to does something else to it that would eliminate the pathogen, then you don't need to worry, you don't need a supply chain control program, but what you will need is then a written assurance from your customer that they're controlling the hazards. That's not really common in the dairy cheese world, but it could be common in other food processing. And so, looking here in this pepper jack cheese model, right, we have pasteurization here for controlling the hazard that's associated with the milk, but the peppers, right, that we put in here, which I think comes down a little farther down here, the peppers that are added are not being controlled by the cheesemaker. The safety of those peppers are being assured by the supplier. So they would have a supply chain program around the peppers in their pepper jack. So those peppers that are in the cheese over there, right, they would need to have a supply chain program around those peppers unless they're doing something special to them within the facility. Now, if you're going to have a supply chain program, you're going to need to have approved suppliers. So again, if I've got an ingredient that requires the supply chain control, I need to have approved that supplier through a process before I start using that ingredient, which means I need to have written procedures for receiving, and we need to have records kept around what's going on to control that hazard. And it can vary depending on the type of hazard. So what are some of the verification activities that we need to do for our suppliers to make sure they have things in compliance? There's a couple things you can do. Ideally, before using these suppliers, you can do an on-site audit of their facility to ensure, right, you're going to review their food safety plan, you're going to, right, audit their facility, make sure that they're producing the food safely, and that can either be done by you or a third party, and we'll talk a little bit more about that later. Depending on the hazard, you might do sampling or testing of the product. It could be done by you, it could be done by the supplier, it could be done by a third party. An example of this might be, right, you're using nuts, right? You've got a nut-encrusted cheese. Those nuts might have issues with aflatoxin, and so the supplier may be testing their nuts for the levels of aflatoxin to make sure that they're acceptable, and that would be one way to verify, right, that you're controlling that chemical hazard. You may also review some other records that they have or the history of that ingredient to decide whether or not you can continue to use it, and there may be other things. But those are the main ones. On-site audit, you'll be doing some testing and then reviewing of their records. Now, if there is a serious hazard, right, the one that is likely to cause immediate health consequences or death, called a Sudoku hazard, which would be, again, things caused by Listeria, Salmonella, E. coli. You are required to then have an on-site audit of that supplier. And it must be done at least annually after the initial audit, okay? Unless for some reason you can come up with enough evidence for why you don't need to do it as frequently. But most people are going to be doing an annual audit of that facility. So who's going to do this audit? Well, it doesn't always have to be you. It can be another party, but it must be done by a qualified auditor. So someone who has had some actual official training on how to audit a facility for food safety. So that might be, again, someone within your facility. There are also large auditing companies. There's SQF. There is BRC audits that are accepted by the industry and by the government as being sufficient food safety audits. It could also be a state regulator, or an FDA regulator. They will be auditing food facilities, and you can get a copy of that audit if they're auditing it frequently enough to meet your yearly requirements. Again, it could also be done by the broker. But you'll notice here, when we're talking about the audit, it's a third-party audit, a second-party audit, or a broker. It's not the facility itself. So you want someone else to be doing that audit of the facility, not the supplier themselves. And that audit is going to need to review, depending on the type of food they are, whether they're covered by HACCP, so like juices or seafood, or their food safety plan. That review needs to be done as part of the on-site audit to ensure they're in compliance. Other verification activities might be like a review of their records, maybe their consumer complaints to understand what's going on there. If it might be something around the controlling of a physical hazard. Depending on the hazard that's being controlled, if it's not as serious, again, it might be something like stones in fruit that are coming in. You might get a certificate of conformance where they're assuring you that they're reviewing each lot before they send it to you and that it will have a low level of stones. Or again, sometimes you'll see continuing guarantees, but they're becoming less common in the industry. Like with all our other preventative controls, FDA wants you to then have a plan in place for what you're going to do if there's a nonconformance. So if I get an ingredient in and it contains salmonella, how are we going to respond? And so you're going to need to go back and do a root cause analysis. You're going to need to verify that if there was an issue at the supplier, what did they do to correct that issue? Maybe they had like a roof leak that introduced salmonella into their product. Did they go back and fix that roof leak and show that it had been addressed? Those kind of things will need to be done. Though I will say that if you end up finding out that a supplier is sending you an ingredient that is contaminated, it is a bigger issue. So, and again, if something like this happens, you're going to need to document it, and records of what was done are required to be kept, because this is all about documentation. Again, for our supply chain program, you're going to need to have a written set of procedures on how you take in ingredients, review that they're coming from the right supplier. If you're bringing in imported ingredients from outside of the country, there's another set of regulations that's called the Foreign Supplier Verification Program, which is another set of conformance for companies that are outside of the U.S. If they comply with this FSVP, then you can accept those documents instead of some of the regular food safety plan documents that we've been talking about today. You need to document that you've reviewed that supplier and have a record that you've actually approved them. You're going to need to have written receiving procedures where they go through and verify that the product has come from a specific facility from the supplier. You'll need to review those records and then determine if there are any other verification activities that you need to do. But most of them will involve auditing and potentially testing. So on the on-site audit documentation, and again, this gets to a lot of the specifics that are required there. The documentation that you get from that company, it needs to say who the supplier is, what's the name of the company, and specifically their location. If they have multiple plants, you need to review the food safety documentation for each one of those plants, all right? What was the audit procedure that was being done? Maybe it was an SQF audit, the date of the audit. What did the audit find? Were they, in compliance? Did they have corrective actions that they had to make? And what did they do to address those deficiencies of the audit? That all needs to be recorded, and you need to have a copy of that. Again, this is for, right, the ingredients that you're getting in from a supplier that have a hazard that you cannot control for in your facility. Again, if they're doing sampling and testing, some of those requirements are the same, right? Again, if we're testing a lot of peanuts that we're getting in, that testing documentation needs to say, well, what was the lot number of the material? How many samples were pulled? What were the size of those samples? What particular test was done? Was it for aflatoxin? Was it for salmonella? What was the date that the test was done? What was the result? Was it negative for salmonella in 375 grams? Or if it was aflatoxin, it was below 10 parts per billion. And then if there was an issue, what was the response to it? Right? Maybe that product was then put on hold and then destroyed, or what. And so, like our sanitation controls, the documentation is a little bit broader than the standard template. But it needs to kind of contain that information, right? So, what is the ingredient requiring the supplier applied control? This would kind of, again, flow from that hazard analysis. What's the specific hazard? What's the name of the supplier? And then the procedures and the documents. And so it might look something like this. So this is an example from FSPCA on what, when you're filling out your preventative control, your supply chain preventative control, how that document might look. But again, the format of this will really vary depending on the ingredient and the type of hazard. And so if we go to the example that's in the back for the pepper jack cheese, you can kind of see what are the outline here for the diced peppers. They kind of, what is the hazard? Hazard analysis determined that there was a potential for pathogens to be in the peppers. And so we need to have a control in place with the supplier. What is the control applied by the supplier? The approved supplier uses a validated blanching, which is a heat process, and brining process that kills the pathogens. How do they verify this? They're going to do a third-party audit, so something like an SQF audit. They're going to do quarterly testing of the product to make sure that it's free of pathogens, and they get a COA from the supplier with each lot that they get. How do they verify that? They review those documents in a timely manner to make sure that they're compliant, and then the records that they get are the specs from their supplier, the letter of guarantee, the copy of the audit, the testing results, and they get also a copy of that validation study for the blanching process that this company uses. And so I know this is a lot of detail. For the smaller suppliers, we were kind of talking about how do we handle this. We were talking about herbs, right? So you may be exempt from this as a small company, or it may be hard to get some of this documentation from if you're buying from a large company, or you're going to Costco and you're buying your herbs. And so what you can do is, again, think about where you're buying them from. If it's from a reputable company, again, Costco, Target, your local grocery store are usually, already have these programs in place with the companies that sell to them, so you can feel a little more assured about using ingredients from those places as opposed to maybe buying, herbs from somebody down the road, that may not have any programs in place. There are also opportunities where I mentioned SQF is a type of audit, food safety audit that's done in the industry. SQF has a website and a database where you can go on there. And so if you're buying, maybe you're buying spices from McCormick, you're a small producer, they're not returning your calls, you can actually go on there and look up the McCormick facilities and see whether or not they've passed an SQF audit. So those are some examples of due diligence, So you may not be required, if you're exempt, to have all this documentation, but you can take the time to do that due diligence to assure yourself, that you're buying products from a reputable company and that your risk then of having an issue is mitigated, rather than just buying it from somebody else. And those are some simple steps when you're starting off to help you do that. So that was kind of a fast run through the supply chain controls. And for a lot of you starting off, you will be exempt from these, but these are things you should be thinking about. So that brings us to the end of our focus portion on the food safety plan. So again, it's all about covering the core components of developing that plan. There are other pieces around the specific requirements around the documentation and how often you have to verify, and which is why I recommend, right, there are other courses on food safety plans, and continue to be taking these, right, to bring yourselves up to speed as you go through the process of building your companies and deciding what type of products you want to make. So hope that was helpful. And I'm here with Taylor for any more time that you guys want to ask questions. So let me know.